Writing code is fun. Creating models with that code can be even more intriguing. But that's not everybody's cup of tea. And things really start getting tricky when it comes to designing a story and presenting our work to our audience, who more often than not you'll find are non-technical people. And this is where visualizations come in. They are one of the best ways of telling a story with data. An effective visualization bridges the gap between what a data science professional creates on his or her own machine and the final outcome which a client or a stakeholder wants to see. Let's begin with an exercise. It's one of my favorite things to get the mind jogging before I dive into the nitty-gritty of why we're here. Have you seen a Rubik's Cube before? It's a puzzle in the form of a plastic cube covered with multicolored squares. The aim is to twist and turn those squares so that all the squares on each face are of the same color. But that's not our aim right now. My question to you is, and take a moment to think about it, how many squares are there in a Rubik's Cube? Can you guess that in less than 10 seconds? A Rubik's Cube has 6 sides with a total of 54 squares. If you figure that out inside 10 seconds without googling it, well done. Most of us, myself included, struggle to do that. It's just the way our brains are wired. Extensive studies have shown how humans struggle with visualizing certain patterns, trends, and even scenarios where angles and shapes are involved. And speaking of our brain, we can broadly divide that into 2 hemispheres. The left side of our brain and of course the right side. These 2 hemispheres control the motion and receive sensory inputs from the opposite side of our body. But what does all of this have to do with visualizations? Well, let's see. The left hemisphere of our brain is responsible for tasks like reading, writing, speaking, logical reasoning, understanding, and so on. This hemisphere processes information sequentially, one at a time. The right hemisphere, on the other hand, handles visual perception. All the patterns we see around us intuitively without realizing, such as the shape of the chair you're sitting in, the color of the walls around you right now, or the various charts that we see in our weekly report. All that happens thanks to the right hemisphere of our brain. I'm mentioning this to show you how an effective visualization or even a chart is processed by your audience. Their visual perception alters when we give them the right impactful visual cues. Broadly speaking, visualization, when you think about it, falls under the umbrella of communication. It's a technique that effectively lets us communicate our ideas to the person in front of us, right? That's the whole essence of it. Instead of words, we're using visual aids. So let's take a moment to understand the power of visualization through the communication lens. Have you heard of the 3 V's of communication? They are verbal, vocal, and visual. Verbal is the words we speak. Vocal is the way we speak them, essentially the tone of our voice, the inflection, modulation, and so on. And visual is a combination of what we present, how we use visual aids, how well we understand our audience to present the right visual elements, and of course, our body language. We'll focus on the first 3 aspects in this course. Now, I want you to take a second to rank these 3 elements of communication in order of the impact. Pause the video for a second and list down your rankings. Which do you think ranks first? Which has the most impact? Got it? Verbal, the words we use, has the least impact. And ironically, most people focus their presentation or their preparation for communication on the verbal part. Vocal, the way we say those words, comes in second, and visual, basically how we present our thoughts and ideas, has the biggest impact on our audience. Just a note of caution, this is not set in stone. This can vary depending on circumstances, but it has held true for the most part over decades. So keep this in mind. Simply put, visualization is a powerful way of communicating our thoughts to our audience. Here's an animated visualization I really like. What do you think this represents? The awesome folks over at the Washington Post created an interactive visualization of the globe where they show the path of the solar eclipse as well as all future eclipse paths until 2080. This shows the paths of the eclipse, the cities which will be affected, and when. Basically, the time is denoted by light and dark shades. I've mentioned the link to the article there at the bottom of the slide if you're interested in reading the entire post. Quite fascinating. When you think about it, the concept of visualization has actually been around for centuries. From the early human age, when humans used to draw symbols in caves and stones to communicate with their fellow beings, to the Renaissance age, when the great Leonardo da Vinci, one of my favorite characters in history, used to keep notebooks on himself where he noted his ideas for machines using visualizations. I'm sure you're already thinking of other examples like these from the ages gone by. And now we're at the stage in the 21st century, thanks to advancements in technology and computation power, that we can generate visualizations at incredibly granular levels, such as our own cells. This, incidentally, is one of my favorite visualizations. Such a beautiful contrast in colors and contours. Don't you love how powerful and effective a visualization can be if used properly? I'm sure you've seen the IBM report where they mentioned that 90% of the data present in the world today was generated in the last 2 years. And guess what? That report came 4 years ago. Can you even begin to imagine the amount of data we're producing right now? Honestly, we're generating data at an unprecedented pace. This is down to a number of reasons, including rapid advancements in technology and consequently decreasing computation costs. But we need effective tools to make sense of the data we're collecting, right? Visualization is one such tool, and we'll see that idea throughout this course. Now, I'm sure a lot of you, especially those who are interested in data science, must be wondering where exactly does visualization fit in? Can we only use it during the exploratory stage? Well, that's one part of it. There's a lot more you can do with data visualization in the data science lifecycle. And that's why I wanted to include this slide and this graph to show you a different aspect of where visualization is effective in a data science project. This is a classic example of visualizing a time series data. The blue line that we're seeing here represents historical data. And the orange line, can you guess what that is? Well, that's the fun part. The orange line is what the model is forecasting based on historical data. This is a time series model visualized in a simple, effective, and easy to understand manner. Don't you love it? So let's put a formal definition to data visualization. What is it? Data visualization, to put it succinctly, is the ability to turn data into visible and tangible insights that people can intuitively understand. This is my definition. I'm sure you have your own when you think about this topic. So as an exercise after this video, I want you to pen down your definition of data visualization, what you understand by it, and we'll discuss that. So now that we understand what it is, let's spend a few minutes understanding the why. Why should we even use data visualization in the first place? Broadly speaking, there are 3 primary goals I feel where data visualization helps us, especially in today's data-driven world. First, it helps us to explore our data. This is where your exploratory data analysis comes in. When we are given data and spend time exploring it, trying to find hidden patterns and trends that were not quite visible when we saw it in a tabular format. We can also explore various hypotheses at this stage. The second reason we use data visualization is to analyze our data. Once we know what data helps us find the answers, we can dig deeper to identify specific items that reveal the answers and find ways to show those answers to our clients and our stakeholders. The time series example we saw just a bit earlier fits into this stage. In fact, if you've used Google Analytics or similar tools, you can also think of those different traffic analyzing features here. And the third reason is, of course, to present our analysis. This is where the communication aspect we covered earlier comes in. We combine a visualization with storytelling and dashboarding to present our final work to our audience. We'll discuss both storytelling and dashboarding aspects in much more detail later in this course. So to truly build and master data visualization, we need to be convinced why we are doing it in the first place. And trust me, that opens doors and opportunities you hadn't dreamed of before. A well thought out visualization peels back the layers surrounding a raw data set. Are there any other broad reasons you feel we should use data visualization? I would love to hear your thoughts in the discussion forum. 4 key elements that go into designing any effective and impactful data visualization. And as we look at each element in a bit more detail after this slide, I want you to visualize Hans Rosling's video, or you can even think of your favorite visualization. Then try to map each element to that, and you'll understand why these are key ingredients in cooking up an effective visualization. The first element, and you might have guessed this already, is of course data. The second element is that of design. This is one we can intuitively connect to when we speak of visualizations. The third brings it all together in the form of a story. And the final piece that completes our key element circle is business intuition. How many of these did you think of before we listed them? Now let's understand all of these in a bit more detail. It's a simple question. What can we do without data? We can't prove or disprove any hypothesis, and we certainly can't analyze anything. So this element involves collecting and storing data, ensuring that the data is clean and ready for exploration and analysis, among other things. Again, recall Hans Rosling's video. He and his team needed to first ensure that they had the correct data before they could consider anything else. Then they considered the element of design. How do we design an effective chart? What components go into that? How do we remove visual clutter and ensure the chart doesn't hold any extra information than what we want the audience to see? Or even something as basic as which chart do we choose for our data? All of this falls under the design umbrella. Then comes the storytelling part, one of my personal favorites. This is when we bring everything together, our understanding, analysis, takeaways to create the final presentation we'll be showing to audience. This element involves us breaking down technical terms into non-technical, easy to understand language, something you'll need to do a lot in the data science world. And finally, we need business intuition. This is the least spoken about element, and I've seen experts just glossing over this when they're mentoring people. It's not how it works. If we don't have domain knowledge, if we can't figure out how a certain variable fits into the business model, how will we ever design an effective visualization? Consider your own domain, for instance. If you didn't know the basics of how your business or how the industry works, would you be able to gather the right data, pick and design the right charts, and put together a story around it? It's not possible. So these are primarily the 4 key elements that combine to make our visualizations effective, impactful, and memorable. You can take a screenshot of this or print it out to keep it handy the next time you're working on a report or a presentation. It's certainly helped me out a lot when I'm starting out and sketching a rough idea of what I want to showcase. Are all of these 4 elements in my presentation? That's a good question. There's no shortage of data visualization and data analysis tools in the market. These tools range from the intuitive ones to the not sure why they're still in the market ones. I'm sure you've come across them and even researched them before you settled on Tableau. There's Microsoft's Power BI, SPSS, ClickView, and other tools like Domo, Looker, Alteryx, among others. There are honestly way too many options to choose from. And then there's Tableau. So why Tableau when there are other options? What makes Tableau such a wonderful and must-have tool for any analytics or data science professional looking to build impactful visualizations? Well, when we compare Tableau to the existing competitors, the difference quickly becomes clear. Tableau is the gold standard in visual analytics for a reason. In this video, I present 7 compelling reasons to showcase the elite prowess of Tableau and why I use it daily in my role even when all the other options are out there. Have you ever heard of Gartner's Magic Quadrant? It's a popular, highly respected and influential annual report by Gartner that helps data and analytics leaders understand and evaluate existing solutions in the market. They release their Magic Quadrant for different domains each year, and Tableau has, till 2019, been a leader for 7 straight years. That's incredible. Just to get on this list is a huge achievement, but to be there for 7 years and in the leaders quadrant, that tells you a lot about how Tableau is viewed by experts and industry leaders. So one of my favorite features of Tableau is how quickly we can transform our thoughts into visualizations. As soon as an idea or thought comes into my mind, when I'm looking at the different variables in my dataset, I can simply drag and drop them into my Tableau worksheet and voila, there's a visualization and instant confirmation of whether my idea works or does not work. This is extremely helpful when you're working with deadlines. This one I'm sure you're already sold on. Tableau has the most intuitive interface I've worked with. The design of any element in Tableau is well thought out, keeping us in mind. We can intuitively pick out the element we want. Take color and size or label, tooltip, so on for instance. The Tableau folks have clearly spent a lot of time working on the icons to make them easy to understand without using text, something I appreciate. Now, interactivity. It's one of my favorite Tableau features, and I'm sure you are going to love it as well. It's almost magical to be able to click on different elements of a dashboard to answer questions. With Tableau, it's also easy to connect to a bunch of different data sources. 67 to be exact. 67 different data sources. Databases, files, big data warehouses, and so on. That is a big number. We can join, union, and blend them in various ways. And we'll see these concepts later in the course. And no, we don't have to pay anything extra for these data connections. It's all built into Tableau. Another reason to love and use Tableau is their pace of innovation. They stay ahead of the curve as compared to the other tools in the market. Take this, for example, Tableau, recognizing that natural language processing or NLP has a huge market right now, included text and speech search in their range of products. Love it. And finally, the Tableau community. It's a place for users who want to connect with other Tableau users, ask questions, learn how to use Tableau, share a feature request, or receive feedback. We can get expertise and examples from the tens of thousands of community members who use Tableau on a daily basis. And I personally love how quickly folks respond and how helpful they are. It's a thriving community. And trust me on this, you will be relying on it a lot as you start using Tableau. Now that we've covered the core idea behind data visualization and why Tableau is such an effective and powerful tool in our hands, are you excited to get started? I certainly am. So let's quickly understand the methodology behind how we've created this course and the different modules that we'll be covering. Most Tableau courses that I've come across in my time in this field have one major drawback. They only talk about the tool. That's fine. It covers the primary aim, that's teaching Tableau. But I feel to actually truly learn Tableau, to truly master it, we need to combine it with our business understanding or our business sense. That is what makes a data visualization rockstar. So throughout this course, whenever we are discussing the different elements of Tableau, creating visualizations, building dashboards, and so on, I want you to put on your business hats and think of the result, the visualization, whatever we create. Think of it from a business standpoint. Because that's what you'll be doing in the industry, right? And don't worry, I'll be prompting this throughout the course anyway. So let's look at what we'll be covering in this course, starting from the next module. We'll understand the different Tableau products available and which one we will use or can use for this course. We'll also cover the installation tips for Tableau Desktop. Then we plan to look at the different options available in Tableau Desktop and familiarize ourselves with the ones we'll be using quite often. Tableau offers connectivity to an amazing number of data sources, and we'll see which ones in this particular module. Then comes our business angle. We will set up the problem statement for this course and understand the different variables in our data set. It's going to be really fun and relevant, so just strap in. At this point in the course, you'll be all set to build your first visualization in Tableau. We'll do that. We'll also play around with labels and colors, understand the different formatting options we have available, learn how to use filters, and build pivot structures just like we do in Excel. I'll also show you how to export your Tableau worksheet into a PowerPoint presentation or simply as an image which you can paste anywhere you want in any report you want. This is where the deep dive truly begins. There's a lot to unpack in this module, including how to build different kinds of charts in Tableau. We will cover some of the most widely used ones in the industry, including line charts and map visualizations for geospatial data. It's a very exciting module. Now, how about feature engineering in Tableau? That's right, we will learn how to create brand new features from existing ones using the concept of calculated fields. I'll also show you how to use parameters to hand over control to your audience and make your work, your visualization, your dashboards much more engaging. Now, this is a slightly advanced topic, but one you'll be using in the industry quite a lot. SQL users will be very familiar with joins, and we'll cover that in this module. We'll also learn about data blending, an advanced but very powerful Tableau feature. Dashboards, of course. This module is all about understanding dashboards, their importance in a business setting, how to build them, how to make them interactive, and much, much more. And that will act as a nice segue into our final module, storyboards in Tableau. We'll cover what they are, why clients absolutely love them, how we can use and fine tune them according to our business need, and finally, we'll build a storyboard ourselves. So, this, to summarize, are the modules we'll be covering in this course. Of course, we'll also have an end-to-end project for you to solve after the course is done. Are you excited to begin your journey into the world of storytelling through visualization? Tableau, as we saw in the first module, is a true leader in this space. But Tableau isn't just one tool or software. It's a multi-headed suite of tools offering different features and capabilities. So let's spend a few moments understanding the various products that fall under the Tableau umbrella. First is the Tableau Desktop, the most powerful tool in the Tableau suite. This is what we'll be working with in the course. Then we have Tableau Prep. This was recently launched by the Tableau team, and I've been quite impressed by how well it works when I need to prepare my data for various sorts of visualizations, reports, etc. It's a very, very handy tool. Then there's Tableau Online and Tableau Server. Both these products offer similar features with a few crucial differences, which we'll see in the next video. And finally, we have Tableau Public. This is a free and light version of Tableau Desktop. Tableau Public is an ideal tool for learning Tableau and publishing your work in a public domain for the community to see and provide feedback. If you can't afford Tableau Desktop, or perhaps your trial version is expired, I strongly encourage you to use Tableau Public as we go through this course. So that was a very high level overview of Tableau and the different products that we can work with. Let's now look at each product here in a bit more detail. It's important to understand what we are working with and when to use which tool. It'll come in handy when you're working on a project and need to quickly take a call on which product is the best fit based on the client's requirement. Trust me, it'll help you out a lot. So Tableau Desktop, the ultimate tool for data visualization and storyboarding. I've used plenty of top quality tools, but Tableau Desktop stands out quite comprehensively. It is the gold standard of visual analytics tools. The ability to create dashboards and storyboards is a must-have for any business intelligence and data science professional. And Tableau Desktop enables us to do just that through a supremely intuitive drag and drop interface. As I mentioned earlier, this is what we'll be using throughout the course. We'll talk in depth about the various features as we progress. Now, Tableau Prep, as the name suggests, is a data preparation tool to clean and shape our data. This process flow that you're seeing on the screen is a typical Tableau Prep workflow. I'm sure a lot of you must have heard the saying, data cleaning takes up 60 to 70% of a data scientist's role. Well, Tableau Prep makes that task a lot easier and much more interactive with its visual cues. Tableau Prep actually is comprised of two products. Tableau Prep Builder, which helps us build our data flows, and Tableau Prep Conductor, which is used for scheduling, monitoring, and managing flows across the organization. Now, the Tableau Server and Tableau Online, which we'll look at in a moment, can overlap in terms of what they offer. So, it's important to understand how they differ. Server helps us share our dashboards seamlessly with the end user or within the organization. It also allows us to connect to any data source, both on-premise and in the cloud. One of the things I personally really like about Tableau is the range of data sources it allows us to connect with. And Tableau Server is no different. Another key aspect is the flexible deployment. Tableau Server gives us the flexibility to deploy our dashboards and visualizations into the organization's existing infrastructure. Trust me, having worked in a big company for over 7 years, it is a very, very valuable thing. Now, if you want the sharing and collaboration features of Tableau Server without wanting to spend resources on managing a server, you should look at Tableau Online. It's a fully hosted solution with no hardware required and no setup needed. It really does work as smooth as that sounds. I've provided a link below this video which explains the difference between Tableau Server and Tableau Online in much more detail. I recommend checking it out if you're curious about it. And finally, we have Tableau Public. You won't see this product outright on Tableau's website, but it's a powerful tool for anyone wanting to learn Tableau without having to splurge a lot of money. It's a free tool with a lot of Tableau desktop features packed in. Keep in mind though that we can't save our work on our local machine. Everything will go on Tableau's public gallery, which, when you think about it, isn't a bad thing. It's a good way to showcase your work to a broad community and get valuable feedback. It's a great way of learning. Most of what we'll be covering in this course can be done in Tableau Public as well, so keep that in mind. So that was all about the different Tableau products you should be familiar with. Let's begin our Tableau journey by first looking at how to install Tableau Desktop on our machines. If you've already gone ahead and installed Tableau, you can just skip this video and perhaps keep it as a reference for later use. Just like everything else about Tableau, installing it is a seamless process. So head over to tableau.com, go to Products and click on Tableau Desktop. So to start off, we'll just wait for that to load. So to start off, click the Try It for Free button and this will get you to the trial page. Tableau Desktop allows us to use the full version on a trial basis for 14 days. And there are no limitations on this trial version, which I honestly find really cool. So here, input your email ID. I've already put that, my own email ID here, and click Download Free Trial. And your download should start automatically. The great thing about Tableau is that it automatically detects our system's operating system and configuration, so we don't need to manually select it. Alright, once the file has been downloaded to our machine, just select it as you can see here and double click it. You'll get this screen. So select the Terms of the License Agreement button. You can read it here if you wish. Select it here. And you can tick or untick this option, which is basically about if you want to share your usage data with Tableau. This is entirely optional, so choose whichever option you prefer. This helps Tableau improve its products if the application ever crashes or something goes wrong. You'll have come across this message often if you use Microsoft Office, so I'll go ahead and untick it, but again, it's entirely your choice. Next, you can go ahead and click Install. We'll say yes here. And nothing else is required from us. Tableau will now install all the required files. If you're on a Mac, the steps are pretty much the same. If you face any issues during this installation process, let us know in the discussion forum for this course and we'll be very happy to help you out. Remember, this entire process might take some time, so I'd say give it about 5 to 10 minutes and the installation should be done. In the next video, we'll look at Tableau Public. In case your trial version of Tableau Desktop has expired and you perhaps are not looking at purchasing the full license yet. That's where Tableau Public comes in very handy. If you've already used up your trial version of Tableau Desktop and perhaps can't yet get the full license for it, Tableau Public is your savior. As we've discussed before, Public packs in a lot of the features Tableau Desktop does. So it's a wonderful tool for learning and experimenting with data in Tableau. To download the installation file, head to public.tableau.com. And just like Tableau Desktop, input your email ID here, I've already put that in, and click Download the app. Your download will begin automatically. Tableau detects our operating system and system configuration, so we don't need to enter anything manually. Seamless, isn't it? Once the installation file has been downloaded, go ahead and double click it, which I'll do here. Now, just as we saw for Tableau Desktop, this will be the exact same process. Select this button, which is basically the terms of the license agreement. You can tick or untick the second option, which is about if you want to share your usage data with Tableau. This is entirely optional, so choose whichever option you prefer. This helps Tableau improve its products if the application ever crashes or something goes wrong. You'll have come across this message often if you've used Microsoft Office. So I'll go ahead and untick this and just click Install. Say yes, and nothing else required from our end. Tableau will install all the required files and you'll have Tableau public ready to go in the next 5 or 10 minutes, depending on your system's configuration. And if you're on a Mac and you're wondering what the process is there, well, it's pretty much the same. If you face any issues during the installation process, whether it's Windows or Mac, let us know in the discussion forum for this course, and we'll be very happy to help you out. And that wraps up our module 2. In the next module, that is where things are about to get very, very tasty indeed. We will take our first step into Tableau Desktop and navigate around it to understand what different options we have. We now have Tableau Desktop locked and loaded on our machines. So in this video and the next one, we'll aim to become familiar with the Tableau interface. This is what we'll be working with for the duration of the course, and hopefully in your professional role. So you should know by instinct where each feature or button is located. I want this to become almost second nature to you. Just like you know what a row and a column is when you look at a table, you should know instantly where each parameter, dimension, label, and so on is located in the Tableau interface. That's how we become a master at anything, right? And Tableau honestly is no different. Practice, practice, and practice. So let's go ahead and open up Tableau. This is the default interface that you'll see. You can think of this as a three-pronged screen: Connect, Open, and Discover. The Connect tab that we see here on the left-hand side, it's pretty intuitive. It has options to connect to all sorts of data sources, as you can see here. We'll talk about the data sources and this tab in a bit more detail in an upcoming video in this module. The second tab here is Open. Again, as the name suggests, it provides us with the option to open a previous workbook that you might have stored on your machine, or load a sample workbook that you can see here. The 3 sample workbooks here are actually excellent resources for learning, so you can explore them too at your own leisure. The third tab here, and it's one of my favorite options in this screen, is Discover. This is curated by the Tableau team and showcases various links that point to the official Tableau site. This includes Tableau training videos here, their selected visualization of the week, and other resources. These training videos under this tab are pretty good if you're stuck anywhere, but honestly I found them a bit lacking. One of the primary reasons actually why I decided to make this course in the first place. Alright, let's go ahead and load up a sample data set. So I'm going to go and say let's click on World Indicators here. So you can go ahead and do that. Perfect. You can see an Excel-like table here. This will be very familiar to you. Tableau automatically populates this once we load the data source. There are other options on the screen such as live and extract, connections, table, and so on. The connections are basically your data source, which was World Indicators for us. And the table is the table that you're seeing here. If you have multiple tables or multiple sheets in an Excel workbook, it will display those sheets as different tables here under this section. And again, we look at that as we move throughout the course. We've understood the basic Tableau interface so far. Let's now dive into the most exciting part of Tableau. So go ahead and click on Sheet 2 here. It'll be Sheet 1 for you if it's the first time you're opening it. So think of yourself as a data visualization or business intelligence artist. And this sheet is your canvas. You have the tools and you have the canvas. Now the real trick, the real genius is in learning when and how to use which tool that Tableau provides in our hands. So as I mentioned, this is the screen you'll be interacting with the most. This, as you can see, contains a ton of features. We have the main menu bar here, which includes things like worksheet, your dashboard, your storyboard, things like how to work with maps, how to format your labels, how to format everything you have in your sheet, how to interact with the server, and so on. The next line, which you can see here, is your ribbon. If you've worked in Excel, you'll be very familiar with that word. This has a list of functions for your workbook, like save your workbook, connect it to a data source, pause auto updates, sort the table that you have in descending order, in ascending order, add text, and so on. Now on the left hand side of your screen here, we have dimensions and we have measures. These are two very important things that we'll be using a lot in this course. So keep them in mind as we progress. These are typically auto-populated by Tableau once we load the sheet. So all these variables you're seeing here are automatically populated by Tableau. Now there might be occasions when Tableau misunderstands a variable and classifies it, let's say a dimension, as a measure. So we'll see how to deal with that later on. In this part, we have formatting options. We have size, text, color, detail, tooltip, we have filters and so on. We'll be using this a lot as well. And this part, this clean sheet, is your canvas. This is where our visualizations, our ideas, and our thoughts will come to life. And this show me feature here, it's actually pretty cool. It automatically suggests which chart you should go with based on your variable selection. In case you can't see this, just press Ctrl, Shift and 1 on your keyboard and it'll show up for you. Ctrl, Shift and 1. So let's do one thing. Let's take up a couple of variables and see how this show me chart works. Trust me, you'll be very impressed. So I want you to now press Shift and keep pressing it. Alright. Select region and then let's open up population and select birth rate. And as you see here, Tableau has highlighted a few charts it feels go very well with these two variables. So let's go ahead and click on this, the recommended one. And here you go. How simple, efficient and clean was that? A note of caution here though, don't blindly follow what Show Me suggests. It's honestly been helpful about 70% of the time for me. Which chart to choose depends on what you want to portray, who your audience is, what the business wants, among other things. So don't just blindly go with a Tableau recommendation. Remember, it's a tool. The business sense is what we have to bring out through it. We'll come across most of these features throughout the course as we work on a real-world project. You're now familiar with the overall feel of Tableau and are raring to get your hands on a data set. Honestly, I'm excited for that too. But just one final aspect before we get there. A look at the different data sources Tableau offers. And trust me, the options we have at hand are truly incredible. Whatever source you can think of, Tableau will have that connection available. So on this starting screen, which we also saw in the previous video, look towards the Connect tab. This is where all the data source options are. We'll mostly be working with Excel and text files in this course, but that doesn't mean you have to limit yourself to that. It should not prevent you from knowing and exploring the other formats, because honestly, in the industry, when you pick up a Tableau role or a BI role, or honestly even a data science role, you'll be working with all sorts of data formats. So don't limit yourself to just one or two. Here, I like how Tableau has divided the data sources neatly and primarily into two categories. Local, which is under the to of file heading, and server, which is under this heading. The local category, this one, is for files that we have stored on our system and includes formats like Excel and text, which we saw, JSON, MS Access, spatial, statistical, and more. There's even an option to upload a PDF file, provided it's in the right format. It's the server category though, which will blow your mind. Here are 4 common data sources. There's SQL Server, MySQL, Oracle, and Amazon Redshift. These you'll have heard of. And these are commonly used in the industry. Now click on the More option here. Wow. The plethora of options we have here is staggering. Any database name you can think of, you'll more likely than not find it here. We have Azure, we have Dropbox, we have Databricks, Cloudera, Hadoop. We even have Google Analytics, BigQuery, Cloud SQL, we have Drive, we have MongoDB as well here. We have MapR, Hadoop Hive, we have SAP, Spark SQL. Honestly, any database that you can think of or you're working with, it will more often than not be here, including Salesforce. In case it's not, again you have options to load it in from here. How cool is that? So no matter which server or what database format your data is in, Tableau will allow you to connect to it and import it. And with such ease. It's no wonder they're a market leader in this space. You can even connect to Tableau server here if your organization is using that in-house. I've made a standalone video for data sources specifically because this is a big part of your Tableau experience, especially when you're working in the industry. I cannot stress on that enough. You'll often be working with data stored in a database outside your machine and in the cloud. So become as familiar with these options as you can. Google BigQuery, for example, it's a very upcoming database, so things like that you should be aware of. and you should be familiar with. Alright, so this was all about the Tableau interface. If you have any questions on different data formats, feel free to reach out to us in the discussion forum and we'll be very happy to connect. And now starting from the next module, we are going to take up a project and start painting our canvas or our workbook with visualizations. Things are about to get very hands-on, so get ready for the ride. This is the Superstore. Store is a one-stop shop for all your home and office furniture shopping needs. The Superstore aims to be the place you think of and go to when you're looking to set up your brand new house or your office, or even perhaps you just want to get an upgrade. Think of Amazon Go or Walmart or even Big Bazaar if you're from India. Just for all your furniture requirements. There are plenty more, and they aren't just limited to furniture items, but we'll keep a focus on that for the scope of this course. You can of course think of other areas where this might apply. That will enable you to think about the bigger picture as well as we go through the course. So let's understand the problem statement at hand. Essentially, the problem we'll be working with in this course. So your client is a superstore in the United States of America and has gotten you on board its data science team. The store has done well in recent years, collected a lot of data, but they've never truly analyzed it in depth. But this isn't the 1900s anymore, where businesses relied more on intuition and very basic sales data to take huge calls. We are in the midst of a data-driven revolution. The Superstore's leadership team has actually been overhauled, and the new executives prefer making data-driven decisions. Luckily for them and for us, Superstore has a lot of data about its products, the different regions in the US where the products are bought and shipped to, and honestly a lot of other variables. So, the Superstore leadership team wants to know which products, categories, subcategories, regions, segments, etc. are doing well in terms of sales and which aren't. This will help them create segments to decide which regions to focus more on, which products need their attention, which perhaps products or categories need to be cut, and so on. I'm sure your head is already swirling with ideas on what kind of variables to look at, what could potentially be a good metric to look at when deciding which products to cut, which to keep, which to focus on more, and so on. Don't worry, we'll get to that soon. So, we'll be spending a lot of time analyzing the data, generating different visualizations and charts to perhaps unearth some hidden trends, dive deeper into the sales numbers, and do a lot of heavy analysis in Tableau. Let's go ahead and load our data set and understand what are the different variables we'll be working with. So, I want you to open up a new Tableau window. And once you see this screen, select Microsoft Excel since we're working with an Excel file. And go ahead, browse and find the sheet and double click it. And let's just wait for that to load. Alright, perfect. So you'll see 3 tables here. These are basically the different sheets in the Excel workbook that we have. There's one for orders, one for people, and one for returns. We'll be working primarily with the orders sheet, but we'll see the use of having different sheets and how to join them later on in this course. That's when the people and return sheet will come in handy. But let's focus on orders for now. Next, I want you to select the orders table, drag it and drop it into this space here. Go ahead and do that. You'll see that Tableau has automatically populated the table here with all the rows and columns, just like how we see it in Excel. So each row here basically represents information about an individual transaction. As I'm sure you've guessed by now, this is a dataset ripe for mining insights. It's waiting for us to unearth the hidden values, and that's what we'll aim to do. Alright, so now Tableau has already populated a new worksheet for us, highlighted in orange that you see here. So go ahead and click that. And you'll be taken to a screen that you must be familiar with by now. Remember how I described this as a canvas earlier? Well, we'll be painting our own stories on it very soon. Now look to the left. Tableau has categorized our columns of variables into dimensions and measures. Can you think of how that categorization happened? Take a moment to analyze these variables and a pattern should jump out at you. Take a second to get it. Did you get it? The dimensions section here has discrete variables such as category, city, country, postal code, product name, etc. And the measures section has continuous variables like discount, profit, quantity, and sales. Now, there might be cases when Tableau wrongly classifies a variable and we need to ensure it goes to the right category. For example, Do you think row ID belongs to dimensions or measures? Well, it belongs to dimensions, right? It's not really a quantifiable variable, it's a unique ID. But just to give you an example of how to move variables from dimensions to measures and vice versa, just drag an instance of your row ID and drop it in your measures. And there you go. And just let's drag it back into dimensions. Just drag it and drop it here, and it's really that simple. But just before you begin your analysis and start drawing up visualizations, it's always a good idea to go through the variables and just check if they're rightly being classified as dimensions and measures. Next, let's spend a moment understanding the data set. This is crucial to any business dashboard that you'll create. I'm sure you've come across this in data science as well. Understanding the data at hand is very important. We can't just jump into the tool and start randomly creating visualizations. That's not how the industry works. We need to be familiar with the data and have a plan before we dive in. So let's see what we have. Just click on data source again here at the bottom and you'll be taken to this screen. Alright, let's just look at each variable one by one. Here we have the row ID, which is unique for each order or transaction in a dataset. The order ID here is an alphanumeric character to represent the order. Columns C and D here, order date and ship date, contain our two date fields. This is where our data structures have the potential to go wrong. Just like in data science, time series data is sensitive and should be carefully analyzed. Then here we have ship mode. Basically, how is our order being shipped? Then we are working with customer ID, another alphanumeric field. Each customer has a unique ID. So let's take Claire Gute for example. She has the same customer ID here. Sean O'Donnell has the same unique ID here, and so on. That's how it is throughout the dataset. Segment here basically tells us what audience this order belongs to or this transaction belongs to. Country, city, state, postal code, and region. These tell us where the order is going to. These 5 variables are our geospatial data, which we'll analyze later. This is some of the most interesting data in this particular data set. This will give us very fascinating visualizations and insights using geospatial maps, as we'll soon see. Then we have the product ID, another alphanumeric variable. Category, which category does the order belong to? Then it's further subdivided into subcategories. Then we have each product name in this variable or column. Now, so far we've looked at non-numeric fields. Now we go to the hardcore numbers. We have sales for each transaction, the quantity of each transaction, discount applied if any, and the final variable is basically how much profit was made on that particular transaction. So, are you ready to generate your first Tableau visualization? So, let's begin analyzing the data in Tableau. You should have the order sheet locked and loaded by now. So, head over to sheet 1, click on it, and you should be seeing this screen. No matter which data source you use, Excel, CSV, Oracle database, MySQL database, honestly any data source, you will be looking at this screen eventually. You will be working with this screen. The first task you should do is look at each variable here and check if it's under the right section. I mentioned this in the previous video, but it's worth repeating again. Make sure our data is correctly aligned before anything else. The second task you should do is check if the data types are being read correctly. What do I mean by data types? Well, you should have string under string data type, the geospatial data being represented correctly as geospatial data, dates are being read correctly, numbers and measures are in order, and so on. How do you identify that? Well, this is where these small icons next to the variable names come into play. So ABC basically represents string. This small globe sphere thing represents geospatial data, and the hash here basically represents numbers. So make sure that everything is aligned properly. Category is under string, customer ID, customer name is under string, order ID, and so on. This is perfect since we've already cleaned the dataset before we got into the video. But it's worth mentioning that you should always check to see if the data types are being read correctly. Let me give you a small example from my personal experience. So I was working on a geospatial dataset where there was a spelling error in one of the city names. Delhi was spelled with 2 L's. Tableau picked that up as a string and not a geospatial variable. Tableau actually has a very extensive built-in geospatial analysis library, but it needs us to make sure that the input is perfect. One small error, like two L's in Delhi, meant that the data type changed completely. And it took us quite a while to understand why this was happening, and we were not able to produce any geospatial visualizations. Imagine the chaos that happened. Also, keep in mind that three-letter codes like DEL or LAL, basically airport codes, will not work in Tableau. It has to be the full city, region, or country name. So, always run your eyes through the data types in both sections, both dimensions and measures, before you get into the analyzing aspect. Alright, it's time to drop a first visualization in Tableau. So, I want you to follow along as I do it on my screen. I want you to do it on yours. So, I want you to double click on sales here. Go ahead and double click it. From here on, I want you to put on your business hats and not just your Tableau ones. Everything we do has to make sense from a business perspective. That's where the power of Tableau will help you in the industry. Learn how to combine your mastery of the tool with your intuitive business sense. So here we have the total sales. Can you guess the number? It looks like it's somewhere upwards of 2000K. But I want to see the exact number. So take your mouse and hover it above the bar, and there you go. Those are the actual sales numbers. But I want to fix this so it's always visible. So go ahead to this T icon and click on that. And there you go. Your sales numbers have been fixed. Perfect. Now, but do you think this is enough? Not really, right? So let's break these numbers down a little bit by the respective categories. So drag and drop your category variable into your columns here. Perfect. Makes a little more sense now. So what's your insight here? Technology here has the highest sales numbers, followed by furniture and office supplies. But here's a question. What if I had 1,000 bars instead of just 3 here? Interpreting it would be a nightmare. Another thing is I don't like how technology is being cut here. It's not ideal. Imagine if you had this entire sheet filled with bars and the x-axis had variables that were being cut. It's not ideal. It's not a good fit. So we need to sort the sales by descending order first. So we have the highest selling category at the top, followed by the second highest, and so on. So go ahead and click on this descending button here. Nice. But does it still look right to you? Well, honestly, it looks fine. It's giving me an intuitive sense of the highest selling categories. But a lot of studies by experts over the years have shown that people tend to visualize things from top to bottom instead of left to right. And I'm not just saying that, multiple studies have confirmed this. Plus, the fact that I just have a problem with technology being cut here. So what I'll do is I'll swap my rows and columns and make this a top to bottom chart, and you'll see how effective that is. So go back here and click on this swap rows and columns button. Does that not make more sense? And now we have the categories fully listed here as well. But there is an exception to this, a case where you should never turn your chart top to bottom. Can you think of that case? When can that happen? Well, that's when you're working with time and date data. You'll never swap anything in that case because it's sequential data, right? We don't want to break the pattern and end up with wrong information. Alright, congratulations on making your first bar chart in Tableau. Go ahead and play around with it, drag and drop a few other variables in, and get familiar with the sort and swap functions. We'll be using that a lot throughout this course. How was your first taste of designing your own Tableau visualization? We designed a bar chart that looked at the sum of sales for each category at Superstore. Technology, as you can see here, is clearly the biggest sales puller for Superstore. That's a good insight for the organization's management team. Now, I want to dive a bit deeper into Superstore's data. Category definitely helps, but we want to help them understand how their subcategories are doing in terms of sales numbers. That's a bit of a more granular analysis and more detailed as well. This you should have done in the exercise before this video, but let's do that here again quickly. So let me just open up a new sheet. Alright, drag and drop an instance of your subcategories into rows and drop sales into columns. There we go. Sort this from high to low like we did previously. This is the button to do that. Perfect. Clearly, phones are the best selling subcategory at Superstore, followed very closely by chairs. What we'll do in this video is look at the different ways to use labels and how to format our chart or visualization in Tableau. And don't worry, we'll look at designing more charts and using other variables to help Superstore in the next module. Right, first I want to zoom in. I don't like this empty space, so let's fill that in. Go here at the top of your Tableau window, click on Standard, and in this drop down, just click Entire View. Looks much better, doesn't it? Next, let's see the sales numbers up front. When we produce or print this report to share with a client or stakeholder, they won't have the luxury of hovering over each bar to see the sales numbers for each subcategory. Not unless they have Tableau Reader. And trust me, the chances of that happening are quite low, quite low. We need to add labels to our bar chart to show the sales numbers. We covered this in the previous video. You can just go here and click on the text button to do that, and there are your labels. There's another way to do this. Let me just remove this. Drag and drop your sales variable under the mark section and drop it on the label cart. And there you go again. This looks good, but we can format it further to add nuance to our visualization. Just go ahead and click on label here to bring up the formatting options. This section, label appearance, basically lets us play around with how the label will look. So you can change the font to whatever you want. You can change the font color as well. And you can also play around with the alignment. So let's see what this does. This gives us a different feel. Looks horrible, honestly, in this visualization. But that's just to give an example of how it works. We'll just revert back to the original one. And you can look at horizontal, vertical things. You can see if word wrap is on or not, and so on. Just play around with it as you want. Now I want you to click on the 3 dots that you see here next to text. I love this. We can add any text in front or after the label. It's super useful to explain things. So here I'm going to add sales and click on OK. So as you can see here, sales has been added in front of each number in our label. Looks nice, but does it have business value? Well, we'll answer that in a second. We can also hide these labels and only make them visible for the bar that's been selected. So let's say a client only wants to see the sales for chairs and tables. So click on label again, and under marks to label, click on selected. And you'll see that the labels have disappeared from here, right? Let's now select the chairs and tables that we want the labels to come for. And as you can see, those two have been selected and the labels are visible for them. It's a very useful thing. Alright, next I'm going to remove the sales text from the labels here because it's fairly obvious what we are looking at, right? Adding sales to each bar just bulks up the visual clutter. I don't want that, right? So just go here and we'll just remove sales. But I want you to keep in mind how to use it because it might come in handy later when we're building dashboards and storyboards. Alright, now to look at more formatting options, right click on the sales mark here and select format. Go ahead and do that. Here, just be careful about which tab you're on. There are 2 here, pane and axis. Pane is the one we want to work with. Axis deals with formatting the 2 axes, the X and Y axis. So we'll get to that later, don't worry. In this pane tab, we have a few options to further format how our labels will look. We covered the font and alignment. Let's look at formatting the numbers. This isn't available under the labels cart here. We can format the way the numbers would look. So let's say you want to display the currency in front of the label numbers. So just go here to numbers, click on currency custom. Let's say I want to look at dollar values. Just do that and you'll notice that the dollar sign has been added in front of each label. I find that to be useful if you're working with a team that sits in a different country. Helps to bring everyone under the same umbrella. We can format the axis in a similar fashion. Right click on the X axis, which is sales, and click on format. This will bring this up again. Just go to axis. Again, I want you to be careful here. Just go to axis and you can play around with the font. You can change the shading. So let's do that here. And you'll see that the color has changed. You can play around with the ticks. You can again change the number. You can add a dollar sign in front of it. Very similar to what we saw under the paint tab. I'm just gonna remove this because I want it to reflect white. Perfect. I'm just gonna go ahead and close this. You can go ahead and play around with this to get a feel for how the different options work. Now, before we head to the next video and look at how the color card works in Tableau, I want to talk about tooltips here. This option that you see under marks. When we hover our mouse over any bar in this chart or any visualization that we'll create later, tooltip that you can see accompanies it showing the variables we have selected. So you have subcategory and sales here. What most people don't realize or don't think about is that we can customize the text we want to show. Go ahead and click on tooltip. So just to give an example, let's change sales to total sales, for instance. Do that and click on OK. And now hover your mouse over any bar and you'll see that subcategory and there's total sales. So that's a very useful thing. Another use for tooltips is that we can add custom text. For example, let's say we want to add a short sentence about what the client is seeing when they're hovering their mouse over the bar. So go ahead and click on tooltip again. Here, I want to show that this bar reflects total sales for that particular subcategory on which the mouse is hovering. So here, let's type this shows the total sales for, and now this is where tooltip becomes really powerful. We can call the variable name, right? So here I'm going to say subcategory, right? And just click on OK. Just type this shows the total sales for subcategory and click on OK. And now you'll see how useful this is. We have the text there. This shows the total sales for copiers, for accessories. Basically, whichever bar you're hovering over, it'll reflect that subcategory name. Pretty cool, right? What I want you to do is basically change the subcategory, try a different visualization, use a different variable, and call that variable when you're doing the tooltip. See how that works. I think of data science as both a science and an art. It isn't just about crunching numbers. It's also about the way we communicate our results in a way that leaves a lasting impact on our audience. Whether that's our client, our stakeholder, or even our team members. That's the reason I wanted to create a separate lesson just to talk about colors in Tableau. We can always play around with the labels and formatting, design awesome charts and visualizations and so on. But using colors wisely takes our visualization, dashboard, and story to an entirely different level. Now imagine this bar chart has to be distributed in your organization or hung up on your CEO's wall. Will you still go with this, knowing that a lot of people will be looking at it? Or will you want to add a splash to it? I personally want to change this up. So let's see how the colors function can help us do that. Go ahead and click on colors here. We can straight away change the color using the default palette Tableau provides. So we can make the bars orange, you can make them pink, you can make them greenish, gray, and so on. Right? So let's go with lightish green here. It's nice. It adds an aesthetic angle to our chart, but it doesn't really add any business value. Let's see how we can do that. Ideally, we want the colors to differ from bar to bar. So what I want you to do is drag and drop subcategory into your color cart. Go ahead and do that. That's a nice contrast as compared to our plain bar chart earlier. We have the legend here as well on the right hand side, which tells us which color belongs to which subcategory. Again, this is visually appealing, absolutely no doubt, but it's still of limited business value. If a client has to individually make out what subcategory each bar represents, then we've lost the battle, we've lost their attention. Additionally, I already have the subcategory on the y-axis here, so not really much point. Let's drop subcategory from colors. This is where I want to show you the true power of this colors function and why I rely on it a lot when I'm preparing my visualizations. We are going to introduce a third variable into the picture. We want this visualization to tell us the profit numbers for each subcategory while keeping the sales numbers the way they are. So how can we do that? It's actually pretty straightforward. Drag and drop an instance of your profit measure into your colors cart. I love this. We've converted a plain bar chart into a powerful and visually appealing visualization. The colors that we're seeing here are telling us the profit numbers for that particular subcategory. You can use this legend to give you an idea of how this is working. The darker the shade of blue, the more profitable is that subcategory, and more towards orange means that subcategory is not quite doing so well. You can always go ahead and edit colors by clicking on edit colors here and choosing the palette that you think suits your visualization the best. So I'll go with red green diverging. That's honestly my default color palette, and you'll see me using that throughout the course. So go ahead and do that. And this looks much better to me. Green represents profit, orangish red represents losses. I think that's a very powerful visualization. You can play around with these colors on your own and come up with similar, or I hope even better visualizations. You've heard me talking about the similarities between Tableau and Excel before. Now, I want to show you an Excel feature that I personally tend to use in Tableau itself. I'm talking about how to build useful tables and sort through them using filters. Does that remind you a bit of pivot tables? Certainly does ring a bell, doesn't it? Now, the Superstore leadership team wants to look at the sales and profit numbers for each category as well as subcategory. They want a nicely prepared table with the ability to sort through these numbers by individual states. So let's see how we can do that. Open up a new sheet and let's rename this to sales profit by state, because that's essentially what we want for each category and subcategory. Alright. First, drag and drop your category to your rows. Next, pick up subcategory and drop it next to category here. Alright. We can see the outline of our table is forming well. What do you think we should do next? We want the sales numbers for each category and subcategory. So drag and drop your sales not to your columns, but instead here inside the table or on the label card. So I'll just drop it here. Nice. Looking like a pivot table yet. Let's sort this from high to low like we always do to get a better feel for a report. Now here we can intuitively see which subcategory generates the most sales under each category. It's a nice report. I like that because there's a clear boundary between each category here, and the leadership team can analyze each on its own merit. Again, think about it from a business perspective. Would you compare every single product against each other regardless of what segment they fall in? Does it make sense to, let's say, compare chair sales to label sales? No, right? It helps to compare each subcategory under its own umbrella category. So, chairs against tables, storage against binders, machines against copiers, and so on. This is a good start to building your own pivot table in Tableau. Now, remember, Superstore's leadership team wants to look at these numbers for each individual state. This is where the filters come into play. So, drag and drop your state dimension into your filters section here. Let's go ahead and select use all because we want all the states to be selected and click on OK. Now we need to show our filter in this sheet. Go to state under filters, right click on that and click on show filter. And there we go. That's way too many options to show to senior leadership or to executives. Nobody has this sort of time to just go and scroll through it. And I honestly don't even like the scrolling option. That's a classic example of visual clutter. Let's remove this visual clutter and streamline it. So I want you to go here next to state in the filters, and we get all these options that you see in this section. Tableau gives us a whole host of different options to show the filter to the end user. So what do you think we should show the Superstore leadership team? The single value slider, as tempting as that is, doesn't make a lot of sense here because we have a categorical field called state. A slider is helpful when we have continuous values. And don't worry, I'll show you that soon. For now, just select single value dropdown. We've now given complete control of this report to our stakeholder. They can choose whichever state they want to look at by simply selecting it here. So let's say they want to look at California, and you'll see the numbers getting updated accordingly. So these are the numbers for California. Now let's look at, let's say, Illinois. And the numbers are updated respectively. That's wonderful. And again, I will say it again. This is very similar to a pivot table in Excel, and I love the formatting and easy filtering options here. Now, let's say we went to the Superstore leadership team with this report and they loved it. They've also asked us to include the profits for each subcategory as well. Now, this is where the slider option we saw just a few moments ago, that will help us. So go ahead and put your profits measure under the filter section. Select sum and just click next. We want all the values included, so don't make any changes to the range and just click on OK. Alright, so we have the profit under the filter section, just right click on that and click on show filter as we did for the state earlier. And we have the profit filter attached to our visualization. Perfect. You'll notice that Tableau by default recognizes the profit measure as a continuous value and it applies the slider, so we don't need to change anything there. You can play around with the slider to look at the numbers you want and the table will be updated accordingly. So let's say the Superstore team wants to see all the subcategories that are operating in losses. I can simply go here, put the maximum value as 0 and press enter. And there you go. If you want to look at profits in the table itself, that's also pretty easy. Just drag and drop an instance of your profit onto your labels cart and there you go. You can see that profits have been added to our table here. Perfect. Go ahead and play around with these filters. Use other dimensions like segment and region to further dive into the data. We've covered a lot of ground in this module. We built our first visualization in Tableau, learned about the different labels and formatting options available to us to create visually appealing and impactful visualizations. And we also learned how to create a pivot table in Tableau using the filters function. Now, as the final video in this module, let's look at how to export our work from Tableau and put that into a report or a PowerPoint presentation. To do this, I'll head back to our sales and profit chart under the subcategory sales sheet. Exporting our work as an image is actually quite straightforward. And no, I'm not talking about taking screenshots. It's a little bit more nuanced than that. So just right click anywhere on your visualization, go to copy and just select image. We get a bunch of options here. Under the show section, we have to choose what features we want to show in the image. I want the title, the view and the color legend, so that's been ticked. You might have caption ticked as well. So since we haven't used captions, just go ahead and untick that. It's of not much use to us. Next, we need to decide what format we want the image in. We have 4 options here, which basically show where the color legend will be placed, as you can see here. So let's go with the default one, which is this one in Tableau, and just click copy. Our next job is to paste this image into a document. So I have a Google Doc open. So here we are, and let's paste the image in here. And there we go. So I can now put a heading above this. I'm going to say sales and profit for Superstore's subcategories. And let me just put that in the center. Perfect. All right. Let's make a small change to this. I don't like that the color legend is taking up all this space here. It's a lot of white space. Let's see what other formats we have. So we'll repeat the cycle again. Just right click anywhere on your visualization, go to copy and just select image. I like this one, which was previously selected, because it'll give me a lot of space for my visualization. So let's just click copy, go back to our Google document. I'm going to go ahead and remove this and replace it with a new one. Looks much better, much better. It gives more breathing space to our visualization. You can go ahead and try out the other options as well. We can also export our worksheet or our visualization to PowerPoint. So all we need to do is go to File on top of your Tableau notebook, just click on that and you'll get the Export as PowerPoint option. Click on that and you'll get 2 options in this drop down: export either this view or export specific sheets from this workbook. By specific sheets, it means the different sheets we have: category sales, subcategory sales and sales profit by state. Since we only want to export this visualization, I'm going to select this view and just click on export. And we'll just name this subcategory sales and click on save. And there you go. Our visualization has been saved in a PPT file. That's how easy it is to export your work from Tableau into a report format of your preference. There are a plethora of charts we can choose from. I'm sure you've come across a lot of them in your professional career, in your college days, and even in your school days. Honestly, if there's one thing we don't lack, it's chart types. Here's a quick overview of the common chart types we typically encounter. And here's the good news: we can easily design all of them in Tableau. Some of these Tableau offers straight up, and others we have to design from scratch. But yes, there aren't any restrictions to what we can come up with. That's the beauty of Tableau. I want to highlight a couple of quotes by famous personalities here because I have honestly personally found them very, very influential. while I was learning Tableau, while I was just getting my hands into data science and visualization. So the first, by the inventor of the periodic table, Henry Hubbard, is he says that there's magic in graphs. The profile of a curve reveals in a flash a whole situation, the life history of an epidemic, a panic, or an era of prosperity. The curve informs the mind, awakens the imagination, convinces. A quite eloquent description of design. The second quote I want to highlight is by a person I respect massively and whose work has inspired me, Edward Tufte. Graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest time, with the least ink in the smallest space. Take a moment to go through this quote again, and you'll realize there's so much he said in just one sentence. His work in the field is unparalleled, and I encourage you once again to read up on it. So, coming back to Tableau, essentially all the charts that are available under the Show Me button that we saw previously, they're all available at our fingertips. It's a simple matter of choosing which one you want to represent your data and just clicking on it. We have bar charts, line charts, pie charts, we have bubble charts, histograms, map visualizations, scatter plots, and a whole lot of other options. I've also included dual axis charts, even though they're not directly under the Show Me section because of how useful they are. Don't worry, we'll cover them in detail in this module. So there's no lack of options. So what our analysis comes down to is this. What's the best chart to visualize our data to get the answers we need? Picking the right one is crucial, as it could make or break your entire presentation. We can also design charts that are not under the Show Me button. Two of my favorites are the waterfall chart, as you can see on this slide, and Gantt charts. Both these require usually using calculated fields before we can leverage them. That's why we won't be covering them in this module, but when we learn about calculated fields later on in this course, you can then try and build advanced charts in Tableau quite easily. I'll provide a list of resources to help you get started with that. Time is the most important factor which ensures success in a business. It's an indisputable fact. Gone are the days when business owners relied on good old intuition and calculators to understand where their business stood over time. I'm sure you've come across the concept of time series data if you've dabbled in data science. It's a complex topic, but thankfully, Tableau makes the role of plotting time series data very simple for us. But just a note here before we proceed, we won't be talking about time series forecasting here. Instead, we'll be focusing on plotting data that deals with the time component. So, how can we represent time series in Tableau or frankly any other tool? We can, as you might have guessed already, use line charts. Line charts are used to represent data over a continuous time span. We typically use it when we need to see a trend or a pattern, or if we want to compare a continuous variable over time. We rely on line charts for a lot of business use cases, including mapping the share prices of a company over time or maybe understanding the earnings per share of a company. Another common use case, which honestly we all do on a day-to-day basis almost, is to see the temperature patterns. You can think of plenty other use cases for line charts where we work with time series, such as population growth, product revenue, sales numbers, points or runs or goals per season in your favorite sport, and so on. In short, line charts are immensely useful. So let's answer the question of why we need line charts in the first place. We understand where they're used. Now let's answer the why part. Line charts let us monitor changes over time. Google Analytics is a classic example of this. I use it extensively to monitor the traffic on my website, and Google Analytics uses line charts to show how the traffic is doing over time, including hourly, daily, weekly, and monthly. Another common use of line charts is for analyzing trends and patterns. Here's a line chart from Google Trends depicting the term data science since 2008. Such an easy yet powerful way to show what the global audience is interested in over time. It's a fascinating use case. Now, this is a line chart showing sales numbers over the years. Does it seem familiar? If it does, it's because this was designed in Tableau. And we'll actually be drawing this up in the next video. A third reason why line charts are useful is for their flexibility. We can compare multiple time series in one chart. This helps us put patterns in contrast and see how they stack up against each other. Here's an example from cricket that I personally really liked. This is a comparison of the first and second inning scores at the 2019 Cricket World Cup. Do you notice any patterns jumping out? If you want, you can just pause the video and try to figure out what's going on here. If you're familiar with cricket or have followed it in modern times, you'll have noticed that chasing is generally considered easier in the modern game. But that was not borne out at the Cricket World Cup 2019, as you can see here. The green line represents the first inning score and the red line represents the second inning score. The side batting first, the green line, usually won, and by a handsome margin in most cases. Loving line charts yet? Let me show you another example of comparing two trends in one line chart. I've taken this from the US Home Sales Survey, and it shows the sales and inventory numbers over a span of 3 years. It's such a simple and neat chart, but it has such an impact in terms of what it's telling us. Trust me, you should become intimately familiar with line charts. They're helpful and they span across almost all domains and industries. We'll be working with the Superstore data again, which you'll be quite familiar with at this point. So let's go ahead and import the data set into Tableau. So I'll just do that. Let's give it a second. Then load the orders sheet and let's jump into sheet 1. Perfect. Alright, so let's first look at the variables we have which contain the time component. Let's just browse through them. We have order date and we have ship date, right? So what kind of analysis do you think we can do with this? How can we use line charts with the order date or the ship date? One thing that comes to my mind is analyzing sales numbers over time. Perhaps the most widely used analysis in the world in any business. You can follow along with me while I do this and then try on your own after the video. First of all, we'll rename the sheet to sales over time. I like to do that first so that I know what's going on when I have like 10, 15, 20, 25 sheets open. This makes it very easy. So let me just rename that. Perfect. So select order date first. Keep pressing Control or Command on your machine if you have a Mac, and also select sales. Now click on the Show Me button if it's not open already. And Tableau here correctly recognizes this as time series data. So let's go with the recommended chart. Go ahead and double click on it. I don't quite like that there's so much empty space on the screen. Let's fill that up. Go here on the drop down menu and select entire view. Much better. Here we have the sum of sales per year for Superstore. There's a clear increase starting from 2017. So the business can then dive into the numbers behind this to understand the reason. But for now, I want to dive into more granular details. I want to understand the sales by month. This could potentially help us unearth any pattern that isn't quite visible when I'm just looking at the year by year report. So click on the plus sign that you see here next to year. Excel users will be familiar with this. Just go ahead and click on it. We now have the sales by quarter. So click on the plus sign next to quarter again. And now we have the sales by month. But do you like this view? Does not seem to be making a lot of sense, and it's actually untidy and disjointed. Doesn't really present a clear picture. I want the lines to be joined so I can see the entire picture in one view. This isn't really helping me at all. So here's what we can do to fix that. Drop the year and quarter from the columns. And there you go. Nice. It seems we have what we need, right? Well, not quite yet. Look at the x-axis here. We have the sales per month, but it doesn't tell me which year the month is from. That's because Tableau has summed up the month for all 4 years and represented it under one bucket. So for example, this is January from 2015 to 2019. Doesn't really help me out. So let's change that. Go back to month here under columns and right click on that. Here we can see the time components in different formats, right? Tableau helpfully shows the format next to them. Since we want month and year together, we'll select this particular month option. This gives us the continuous month. Go ahead and click on this. And voila, we have the sales numbers for each month in our data set. Now, does anything jump out at you? Again, as I keep saying throughout the course, just pause the video for a second and try to figure out if there's any pattern that's coming out. Personally, I can see that there are 3 months that are spiking up my sales. September, November and December, and that's happening pretty much every year. Look at this, September, November, December. Again, September, November, and December is not quite there yet because we don't have the full data for December 2019. But it's a clear pattern, right? September, November, December. These 3 months seem to be helping Superstore spike up its sales. This is super helpful for a leadership team, for a management team, because the business can now dive into the numbers and figure out the reason for the spike. Is it because there are certain holidays during this month? It's possible, right? December has Christmas. September could potentially have something else, so it's definitely possible. Superstore's leadership can now apply these learnings for the other months of the year and see if it works or not. See how helpful line charts are. This pattern did not jump out at us earlier when we were looking at the year by year pattern. So just take a moment, structure your thoughts, think about how you can potentially dive into what data you have, and this is how useful it can be. Now, we're not quite done yet. Let's say we want to compare the sales of two subcategory of products over time. I am going to pick those at random here, and you can choose the ones you want to analyze. I'm going to use the filter and color functions that we have. So let's go. Drag and drop an instance of subcategory to your filters. I'll select chairs, furnishings, and let's say tables. Click OK. Next, drag and drop subcategories again, this time to your colors cart. Before I just drop it there, just think about what will happen to the chart that we have. And here we go. Chairs are clearly the best-selling item. You can check the legend here for the colors. So you can think of examples from your own domain that will apply in this kind of comparison. It's a lovely chart. I'm a big user of apps like Uber, Zomato, Swiggy, Deliveroo, etc. I use them a lot. And coming from the data science industry, I am intrigued by how these organizations all map their routes to optimize the time it takes to deliver my order or get me a cab. Or even aspects like how organizations scale up their logistics operations to ensure the supply chain is the best in the business. Or how about even something like analyzing your sales numbers to understand which customer segment in which geographical location is giving us the most revenue. All of these things, all of them, are possible these days thanks to the ability to map location data. Now here's the thing. Organizations collect information in the form of rows and columns. That's a typical spreadsheet where we see columns like latitude, longitude, etc. That does make reporting fast and easy. I absolutely agree with that. But it does not necessarily make it more insightful. Here are the relevant columns from our Superstore dataset. We have location data, we have region, city, state, postal code, and then we have measures like sales, quantity, discount, and profit. But how useful is this to us in its current form? How do we map this location data to the sales and other numbers so that our clients and stakeholders instantly jump up at what they see? This is where geospatial analysis comes in. Thanks to geospatial analysis, we can collect, gather, store, and analyze location-based data for our business. It's a powerful concept that has spawned a ton of business ideas around the world. Maps make it easier for us to recognize patterns that were previously buried in spreadsheets. This, as you can see on the slide, is a classic map visualization in Tableau that shows sales numbers by state in the United States. In an instant, we can recognize which state is doing well and which isn't, and the business can use that to retool its strategy. We'll be drawing up a very similar visualization in the next video. Now, you must have come across different use cases of geospatial analysis. Here are a few popular ones that I personally really like. We can use them in sales and marketing to understand customer segments, which region is doing well, and so on. Organizations use geospatial analysis to create and optimize their transportation and logistics strategy. In short, supply chain management. Situational awareness or intelligence, such as understanding which are the crime-ridden areas to help the police patrol them, is another example. Risk analysis to help insurance companies understand which areas they might be overexposed in. Organizations even use geospatial analysis to understand where they can potentially expand their operations. The interplay of several factors helps the leadership and management team decide if a region is worth exploring or not. Saves a lot of time, effort, and money. And satellite imagery, of course, is a popular geospatial analysis use case. Every time we use Google Maps, to gauge how long it will take to get from point A to B, we're interacting with geospatial analysis done through satellites to map the traffic. I'm sure you've thought of this one even before I started this video. Honestly, there are many more applications that you can read about with a quick Google search. Let's get down to understanding and using maps in Tableau to help Superstore optimize its sales strategy. I gave you a little taste of the geospatial variables in the previous video that we have here. Can you recall which ones they were? Take a moment to go through the dimension section and mark out which ones you think we can use. Here's what I have: city, country, postal code, region, and state. In this video, we'll be leveraging the state variable. Now here's what I want to do. We'll look at the different measure values by state by plotting all of this on a map visualization. So we look at sales, profit, and even quantity, each by state. First, let's rename our sheet to numbers by state or measure values by state. Right. So what's the first step? Select the state and the sales variable and open up Show Me. Let's go with the recommended graph. Just go ahead and double click this. That's not quite what we were expecting. This gives us a world view rather than the map of the United States. So what went wrong here? See the 49 unknown message here. Go ahead and click on that. What's happening here is that Tableau does not quite recognize the state names. That's because there are certain locations around the world with the same name and the exact same spelling, such as New York, Washington, etc. And Tableau can't quite map it without us telling it so explicitly. So go ahead and click on Edit Locations. Here on the Country Region drop-down, click on From field and you'll see the United States has popped up behind correctly. Go ahead and click on OK. And here's our first map visualization in Tableau. But wait a second, does this look like the final version of what we want? I can't quite discern anything substantial from this. So let's do one thing. Click on the drop-down under Marks and select Map. Much better. But you'll notice that sales is being shown under size here. That makes no sense since the state size won't go up and down on a map, right? That remains constant. So let me just remove that and drag and drop sales into my color cart. Better, right? Our map of the United States now shows us the sum of sales per state, classified by color. So states like California, Texas, New York, all of these have higher sales and they're represented by a darker shade. This color scheme that you're seeing is the default color scheme in Tableau. I want to change that up a bit to give my stakeholders a better feel and to make my visualization much more impactful. I don't want them to just hover over each state to understand if it's doing well or not doing well. So head over here, click on Edit Colors, and from this drop down, select the color scheme that you want. I usually prefer the red-green diverging as it offers the right amount of color contrast. So let's click on that and click on OK. Well, this might not be what you're looking for depending on your client. Ideally, we don't want red all across the map if you want to showcase burgeoning sales. Not quite the right representation. So you can always go to Edit Colors and choose something else. Let me, for example, go with green and blue diverging. So this is slightly better, right? This gives a more positive feel to the entire visualization. Now, instead of sales, let's say I want to analyze profits per state. All I have to do is remove sales and drag and drop profit into my colors card. That's it. And here the red-green diverging makes much more sense, right? The green shows states making a profit. So New York, California are making a profit, but this time Texas is not. Remember, Texas is one of the highest sales numbers, but when it comes to profit, it's not quite that. It's a very useful insight. So go ahead and play around with the colors and the numbers, and there are a lot more insights that you will come up with. Finally, let's also try quantity per state to get a sense of the order numbers per state. So we'll follow the same steps, remove profit and drag and drop quantity into your colors card. And there you go, we're back to the default Tableau color scheme. Quite unsurprisingly, when you look at this visualization, the states with the most sales numbers, California, Texas and New York, they have the highest quantities. It's a simple example of how we can combine numbers and visualizations to generate powerful insights for our business. We'll see maps again in the next module when we work with calculated fields and parameters in Tableau. For now, I want you to keep practicing and playing around with these visualizations. Go ahead and try out something else. There are a remarkable number of charts and graphs we can come up with in Tableau, and we saw that in the first video of this module. So far, we've covered the line chart and we also saw how to visualize location data using maps. In this particular video, I'm going to focus on a few other charts that you're almost guaranteed to encounter in your own data visualization journey. Let's dive straight into Tableau and design each one by one. So let me just open up a new sheet. We drew up a bar chart earlier, but let's do that again because I want to 1. Emphasize its importance and 2. Show you how useful it can be again. Bar charts are honestly easily one of the most commonly identifiable visualizations in business. As Tableau themselves put it, these bar charts let us compare data across categories, highlight differences, show trends and outliers, and also reveal historical highs and lows at just a single glance. Bar charts are especially effective when we have data that can be split into multiple categories. Here, I want to analyze the sales numbers for my product subcategories. So, drag and drop subcategories to your columns and sales to your rows. And there's your bar chart. Let's sort this from high to low because I always honestly prefer that. It's much easier to look at and analyze. I don't quite like the way the labels are on my x-axis. I don't like the 90-degree angle there. Makes it difficult to read. So let's flip it. This button that you see here basically swaps the rows and columns. So with one swish, you can rotate your chart. Go ahead and click on it. Much better, much better. I have a better sense of the sales number per subcategory. Let's rename this sheet to subcategory sales. Always, whenever we are analyzing numbers and designing visualizations, and I know I keep repeating this, but it's really that important. I want you to think of it from a business perspective and not just from a Tableau or a tool point of view. This will help you hone your analysis skills and will make you sharper and quicker at recognizing patterns in a jiffy. Next, let's do a histogram. Open up a new sheet. A histogram shows the frequency of a measure. How is it different from a bar chart, you ask? Well, a bar chart analyzes two variables, a histogram, only one. Let's see how to make one in Tableau. We'll look at the amount and frequency of quantity at our superstore. So select quantity and head to show me. Select the histogram that you see here. Just click on it. And there's your histogram. Do you think the x-axis makes sense? Tableau has made bins automatically, but quantity is not a continuous variable, right? It's a discrete variable. So let's change it. So click on this here and click on discrete. And there you go. I want the entire sheet to be filled up. So select entire view from this drop down and there you go. Perfect. We can see that 2 is the most common quantity at Superstore followed by 4 and 5. Let's rename this sheet to quantity analysis. Let's jump to scatter plots next. Open up a new sheet. So scatter plots help us visualize the relationship between two measures in Tableau. I'm sure you've used scatter plots plenty of times if you've even analyzed the relationship or the correlation between two variables in data science. A scatter plot essentially presents lots of distinct data points in a single chart. So drag and drop an instance of your profit variable to your rows and sales to your columns. I want to see if I can make sense of their relationship. So here's a scatter plot, but it only has one point. It just shows the total sum of sales and the sum of profits. Let's populate this chart. Drag your subcategory variable and drop it into your colors card. Can you figure out what's going on here? Before I just drop it, just pause the video and think what will happen to the scatter plot. Use your business sense. And here we go. This scatter plot shows the relationship between profit and sales for each subcategory of Superstore. You can play around with the measures and look at the different relationships here. You can even put subcategory into filters and analyze 2 or 3 subcategory products that you want to get a better sense of what's going on. Let's rename this sheet to profit and sales. Alright. A bubble chart. Have you heard of a bubble chart before? It's a personal favorite of mine, but it should be used with caution. It looks visually appealing, it really does, but it has certain limited use. A bubble chart basically visualizes the relationship between dimensions and measures. We can vary the size and color of circles to design visually compelling charts that present large volumes of data at once. In our Superstore case study, we'll use a bubble chart to look at the sales per subcategory. This will be pretty straightforward. Select sales and subcategory, hit show me and select the bubble chart right at the end here. It does look visually appealing, doesn't it? I'll just fit this into the entire view and there we go. The size of the bubble that you're seeing here represents the sales numbers. So the higher the sales, the bigger the circle or the bubble. This is fine when there are a few categories, but it's not a great option when the categories are numerous. Let me show you an example of how it can go wrong. So let's try out product name for example. Replace subcategory with product name. So I'll just do that. Are you seeing what's happening here? This, while it looks nice, it's a nightmare. It really is a nightmare. I mean, it has absolutely no business value. So be careful when you use it. So let's undo this. You can either press Ctrl Z 2 times on your keyboard or just go to this button and click twice on it and we are back to our original screen. Let's rename the sheet to subcategory sales. And we'll put bubble here just to make sure differentiated from the bar chart that we created earlier. Now, how about a pie chart? I'll be very honest with you. I haven't seen a chart polarize opinion as much as a pie chart. Industry veterans that I've interacted with either love it or absolutely hate it. Wherever you stand in that debate, there's no doubt that there are certain situations where pie charts are useful. They help us see segment-wise data, for example. So let's do a segment sales pie chart. Just to refresh your memory, we have 3 segments in Superstore. We have consumer, corporate, and home office. Let's see how each of them does in terms of sales. So select sales and segment, go to show me and select the pie chart that you see here. And we'll again click on entire view to zoom in. Now I want to see the numbers up front, so select the text button. The consumer segment, the one in blue, is more than half the sales. That's useful insight for the Superstore leadership team. And that is how easy it is to create a pie chart in Tableau. Let's rename this sheet to segment sales. You can of course play around with other things. You can play around with region. You can even try out, let's say, subcategory in your pie chart and see what share it has in your overall revenue and so on. There are other advanced charts as well you can drop in Tableau, such as Gantt charts, waterfall charts, donut charts and so on. But those require advanced features like calculated fields. So once we are done with calculated fields and parameters in the next module, you can go ahead and try those out. You now have the hang of the core visualizations that you will be working with in the industry and how to make them in Tableau. Even more importantly, you also know when to use which visualization. So you don't have to waste time trying out every one before settling for the one that works. Now coming to this video, I want to talk about a technique in Tableau called dual axis charts. They're quite handy when we use them correctly. That's important. They are useful for illustrating the relationship between 2 or more measures, especially when those measures are of different scales, such as sales and profit in our Superstore case study. Just keep in mind that any continuous variable can be used in a dual axis chart. So let's see how to draw up a dual axis chart in Tableau. Since I mentioned sales and profit just moments ago, let's go ahead with those measures. And we'll use a subcategory dimension as well to design our first dual axis chart. Go ahead and drop the subcategory variable to your columns. But before that, let me just open up a new sheet. Alright. Now go ahead, drag and drop your subcategory variable to your columns. Next, drag and drop your sales and profit next to each other in the rows. So I'll go ahead and do that. We have some sort of visualization here, but I can't honestly make much use of it right now. Let's turn this into a dual axis chart. Go to profit here, click on the down arrow or right click it and select dual axis. Click on that. Nice. Did you see what happened here? We have 2 axes in one chart, but both these axes are of different scales, sales and profit. We need to synchronize the axis to make sense of this visualization. So click on the profit axis and select synchronize axis. Go ahead and do that. Now both the sales and profit axes are now on the same scale. And this is where the dual axis chart starts to make sense. Notice under the mark section here that we have different fields for sales and profit. We can play around with this and drop different charts. For example, let's say I want my sales to reflect as a bar chart. So click on that, go to this drop down and select bar. See how useful this is. Now let's say I want to turn my profits into a trend line instead of the circles that I'm seeing here. So click on profit, go to this drop down and click on line. And there you go. Dual axis charts are awesome. Let's take things up a notch again and introduce a date component into the picture. Yes, I'm talking about a date dual axis chart. So go ahead and open up a new sheet. I want to look at the sales and profit numbers against the order date. This is actually going to be very simple if you got the idea behind dual axis charts in the previous video. So drag and drop your sales and profit variables right next to each other in the rows as we did previously. Now this time instead of subcategories, we'll use order date in the column. So go ahead and drag and drop it. Right. So we have two different charts here. Remember what the next step was? We'll use dual axis to combine them into one chart. So go ahead, click on the drop down or right click on profit and select dual axis. So what next? That's right, we'll synchronize the two axes. So right click on profit and click on synchronize axis. I'm just going to go ahead and put this into entire view so that the screen fills up. Perfect. Next, I want the sales and profit by month. I don't want it by year as you can see here on the x-axis. If you recall, the month by month analysis was much more useful to us earlier. So I want you to pause the video and change this chart to a month on month view. Don't look at what I'm going to do next. Try and do it yourself. It's a good way to learn. Done? Let's see. Simply right click on year here in the columns and select the continuous month format as we saw earlier. And there you go. This is our date dual axis chart. Looks great and it puts both sales as well as profit into contrast for each month in our data set. It's very useful when you think about it. I encourage you to play around with the ship date and the order date along with sales and profit to see what you can come up with. We have a solid intuition behind the Tableau interface and how to create a basic visualization and play around with the formatting and features like size, color, and so on. Now, let's dial things up a notch in this module. What if you're faced with data that doesn't have a lot of information? What if you wanted to create new features or variables? Can we do that with Tableau's drag and drop interface? Can we do feature engineering in Tableau in short? Yes, we can. Welcome to the wonderful world of calculated fields in Tableau. These are honestly one of my favorite features of the tool that let me expand my horizons and experiment with more data than what I initially started with. As I mentioned, you can think of it as feature engineering in Tableau. Does it remind you of Excel? The ability to use formulas and engineer new fields. It's such a handy feature when we are working on real world projects. I've used calculated fields in pretty much every single Tableau project I've worked on, so make sure you spend a lot of time experimenting with this. Let's put a formal definition to calculated fields. What exactly are they? Calculated fields essentially allow us to create new data or columns or features from the existing data that we're working with. Do you see where the feature engineering concept comes in? So don't let anybody tell you that Tableau is just a drag and drop interface. It's so much more than that. I'm sure you're already thinking of different ways you can use calculated fields. Let me show you 5 examples from my own experience where I've leaned on calculated fields to improve my dashboard and my final presentation. Segmenting data, such as new versus returning customers, married versus unmarried, and so on. Converting data types, such as converting a character column to a date column, and so on. Aggregating data, such as grouping features or variables together, sorting and arranging the columns as per our requirement, etc. Filtering results. This one I'm sure will ring a bell. It works the way exactly as it does in Excel. It lets us filter out results we don't need or if we want to focus on one specific area. And finally, calculating ratios. We can create new features by either adding, subtracting, multiplying, or dividing 2 or more columns. Honestly, you can do a whole lot more based on the domain, the data set you're working with, and how curious you are to explore the problem. So, what kind of calculations does Tableau allow us to do? We can broadly divide this into 3 categories: basic calculations, LOD or level of detail expressions, and table calculations. Basic calculations allow us to transform values at the data source level of detail or at the visualization level. LOD calculations also allow us to engineer values at the data source level and the visualization level. However, these LOD calculations give us even more granular control. We can use commands like include and exclude to get to the bottom of what we are working with. And table calculations finally let us transform values at the visualization level only. Now, you might be wondering, what in the world do I mean by data source level and visualization level? It's actually quite simple. Data source essentially means row level calculation, and visualization means aggregate level calculation. Don't worry, we'll be working hands on with calculated fields in the next video of this module, so you'll be able to relate back to this with quite a lot of ease. Here's a quick look at what a calculated field looks like in Tableau. Don't be daunted by the amount of lines. This is actually a very simple formula that lets us perform feature engineering with date variables. You'll have this handy as soon as we finish the calculated fields module, trust me. You can actually pause the video here and just go through this formula. Are you ready to get hands-on with feature engineering in Tableau? We set up the base for it in the previous video, so let's dive straight in. We'll be working with the same data set where we have data about the different orders for a superstore. I've loaded the Excel file again, so I'm starting this from scratch, but you can either continue on the same workbook we had before or open up a new instance of Tableau. It's entirely your choice. Alright, we have our measures and dimensions here, which honestly we're very familiar with at this point. But before I move ahead, I want you to pause the video, just take a minute and go through both these dimensions and measures. Just do it once again. But this time, think about what different features you can create using these existing variables. We will be, of course, using calculated fields to generate those features. So put on your business hat and note down what you can come up with. One thing that comes to my mind is to figure out what's the shipping time for each state. Think about it. The lesser the shipping time, the better your supply line, right? We can get orders out quicker in a cost effective manner if we can just figure out what the logistical system is for Superstore. So let's see which variables we can use to calculate the shipping time. What do you think? We can use order date and ship date, right? Order date is basically the date when the customer placed the order, and ship date is, of course, the date when the order was shipped from Superstore. Right, so let's go ahead and create a calculated field. There are multiple ways to do this. One way is just find an open empty space in your dimensions or measures and just right click and click on create calculated field. Another way to do it is click on analysis at the top of your Tableau workbook and click on create calculated field here. The third way to do it, and the way I do it, which we'll see multiple times in the course, is click on this drop down arrow next to dimensions and click on create calculated field. So go ahead and do that. Alright, this is what the calculated field window looks like. Let's first give it a name. I'm going to name it shipping time since that's what we're going to calculate here. We can put the formula in this blank space. Before we do that, just one thing. Notice the arrow here. Just click on it if it's not open for you. Here we get basically the entire list of functions in Tableau for calculated fields, just like we do in Excel. You can click on this drop down menu to narrow your search to what we want for our example. If you want the difference of two dates, which is exactly what we're looking for, go ahead and click on the date here and click on date diff since we're looking for the difference of two dates. What I like is that we have a full explanation of what each function does. So you'll get that here towards the right hand side. So the date diff function, if you've used it in Excel, is the same thing, but in Tableau we have an extra F. It returns the difference between two dates, where start date is subtracted from end date. And you can see an example of how it's used here. So let's go ahead and double click this. Here we go. And just like in Excel again, and I keep harking back to how similar these two are in terms of a lot of things, the tooltip shows what we need to enter in the parenthesis. So as we can see in the date part, we want the days. So put day all in small and close that. The start date is of course our order date. So go ahead and drag that into your calculated field. Perfect. And our end date is of course the ship date. So go ahead and drag and drop that here into your calculated field. Perfect. The final thing is start of week, but that's an optional thing and we don't really need it here. So we'll go ahead and skip that. Another way to do this, and a simple way, is simply drag order date minus ship date and put that here. You'll get the same result. But I'm using the formula here to give you an example of how you can use different functions in Tableau to create calculated fields. And honestly, trust me, we'll be using this a lot in this course, as well as when you go out and do projects in Tableau. Okay, before I click on OK, another thing is you can see the calculation is valid. Tableau is telling me that it is fine. So if I remove this bracket, I'll get an error here. The calculation contains errors. It's a good way to just quickly look at if your calculation is working or not. Just rely on that. All right, so let's go ahead and click on OK, do that. And voila, we've just created our first feature. Tableau automatically recognizes it as a measure and hence places it below the measures section. Perfect. So what's next? How do we use this shipping time variable? Well, we want to see the shipping time for each state, right? That'll give us a good overview of what the logistical setup is for Superstore. So I'm going to go ahead and select shipping time as well as state. Now, click on the show me button here. So we get a few charts. I'm going to go ahead and click on the recommended one. So go ahead and do that. That's not quite doing it. It takes a world view rather than a state view. Why do you think that's happening? Do you see this 49 unknown errors here? Click on that. We're getting this because our machine does not recognize where the state variable is coming from. If you're familiar with a lot of geographical locations around the world, you'll have noticed that there are a lot of double names. So, New England, there are two places for New England, and so on. So, Tableau does not intuitively understand where that location is, and we have to manually do it. So, go ahead and click on Edit Locations. Now, under Country Region, select From field, and you'll see United States is popped up behind. So, that's exactly what we want. Perfect. Go ahead and click on OK. That's it. And we have the United States map, but we still don't have exactly what we're looking for. So I want the logistics setup. I don't want these dots appearing. So to get another map, a better map, go ahead, click on automatic here and click on map. Perfect. This is exactly what we were looking for. What do you think these colors are telling us? Go ahead and hover your mouse over them. As you can see, we're getting the shipping time for each state, but is this what we were looking for? Not quite. As you'll see here, it's giving us the sum of the shipping time. We want the average for each state, right? We don't want the sum. So click on this, go to measure sum and click on average. So I'll just repeat that and click on average. All right. Now hover your mouse over it again and you can see the average shipping time for each state is coming up. That's pretty helpful. A lighter color tells us that it's a short time and darker means a longer shipping time. But I'm still not happy with these colors. It's not intuitive at all, right? So I'm going to change that up a bit. So take your mouse here on the average shipping time control, click on edit colors. Click on automatic and you'll get a whole plethora of options you can use from. I generally go with red green diverging because a lot of studies have shown that it offers a very good contrast and it works very well. So I by default I go to red green diverging. You can of course experiment with different colors. So for the purpose of this example, we'll go ahead with red green diverging. Alright, just click on OK. Much better. But you'll have noticed that red here represents a faster shipping time, right? Look at this. Maine has an average shipping time of 5 days. New York has 4.056. Yet, when I look at this chart, I get the feeling that New York has a much higher shipping time than Maine. That's not what it's representing. So let's go ahead and reverse these colors. Again, go back to your control, click on edit colors. This time just select reversed. And there you go. Perfect. A much better chart that shows us the shipping time for each state. Next, let's put a threshold value that tells us whether the shipping time is adequate or needs to improve. That'll be a key performance indicator or KPI, right? Because we need to understand, we need to set a benchmark and understand if the shipping time is as per Superstore's requirement or not. I'm going to go ahead and take this shipping time or the benchmark for the shipping time as 3.5 days. So anything over that needs to be looked at. To do this, we'll once again head over to edit colors, click on advanced and just tick on the center and we'll set it to 3.5, right? And click on OK. Boom. The entire picture has changed again. Taking 3.5 days as a benchmark for shipping time, Superstore needs to look at its supply chain pipeline to improve this. There are most of the states have a shipping time, average shipping time of over 3.5. That's clearly something that Superstore needs to improve. And that's how powerful visualizations are. One question that comes to my mind is, could this have something to do with the volume of orders? Maybe the red color is representing states where the volume of orders is much higher than those in green. Possible, right? So, as an exercise, I want you to figure out the number of orders placed for each state. That will require some clever feature engineering using calculated fields. So, whatever we've learned here, just put it into practice in the assignment. Having fun with calculated fields yet? In this video, we'll take things up a notch again and interlink two calculated fields. I want to understand what the average order value is for Superstore's products. This can open up a lot of helpful avenues, such as evaluating which subcategories are doing well as per the average order value and so on. So, to put a mathematical definition to it, average order value, in its most simplistic way, is the total sales divided by the number of orders. I'm sure you've already calculated the number of orders in the assignment we did before this video, but in case you haven't, don't worry, we'll do that in this particular video. So, let's go ahead and create a new calculated field. We'll name this as the number of orders. Go ahead and name it as per your comfort. Now, the function we need to use here is called countD, right? So I'll go ahead and type this out. And this is the function you're looking for, which returns the number of distinct items in a group. That's how we calculate the number of orders. So drag and drop an instance of your order ID into the calculated field. And Tableau tells us that the calculation is valid. All right, go ahead and click on OK. Perfect. We have the number of orders under measures. Exactly what we wanted. Next, we'll create another calculated field to calculate the average order value. We already have the denominator as a number of orders, remember? So go ahead and create a new calculated field. This one we'll name as average order value. The formula for this, and you can type along as I go, is sum of sales. Remember to close this bracket divided by the number of orders we just calculated. And again, the calculation is valid. Now you might be wondering, why did I use sum to aggregate sales but not number of orders? Take a moment to ponder this. That's because orders already has an aggregation of count D in the calculated field which we created just a moment earlier. Tableau does not allow us to mix aggregated and non-aggregated fields within a calculated field. An important point to note. So let's go ahead and click on OK here. And we have the average order value under measures. Let's verify if we calculated everything properly. Because even if Tableau shows us that the calculation is valid, it does so from the syntax point of view, not from the actual business result point of view. So I'll create a quick raw table to verify this. Drag and drop measure names into your rows. Then drag and drop measure names again. This time, do it under filters. So you should see this particular window pop up. Select the three features we want. So I want average order value. I don't want discount. So I'll just select the ones I don't want. So I want average order value, number of orders, and sales. Right? Select those and click on OK. Alright. Finally, drag and drop measure values. We'll find them here at the bottom of the measures section. Drop them onto your text section. And there you go. The average order value is $459 on just over 5,000 orders. And the sales value, which we've seen earlier as well, is correct. So I can verify that the average order value has been calculated correctly. Just a note here, if you want the currency sign next to the average order value, simply right click on the measure. Let's go ahead and click this. Go to select default properties. Click on number format. Here go to the currency setting and just put dollars here if you want. And just click OK. And there you go. You can do that for sales as well. Looks a lot neater honestly to me, so that's why I did it. We've created two calculated fields in the previous video. The number of orders and the average order value. Now it's time to put on our business hats again and figure out the average order value for the subcategories we have in our dataset. This will really help Superstore understand which subcategory is doing well and which isn't, based on whatever the initial targets were. You can of course play around with those targets on your own after this video and enhance what we learn here. This is a classic business problem that pretty much every business aims to solve. And we get to do it live here. That's exciting. So how do you think we can figure this out? Will we need to dip into our reserves and formulate a complex equation? Not quite. We'll be using if-else statements to help us out. Honestly, I ideally aim to avoid if-else statements when I'm working on a project, but there are times when this is really useful. And you should know how if-else statements are made in Tableau. You'll need it to clear any interview when you're relying on Tableau to help you out. It's just good basic hygiene. I want to first look at the different subcategories I have. So let me go ahead and open up a new sheet here. Let's name this AOV for subcategories. AOV being average order value. So let's do that. All right. So let's go and drag and drop subcategories to your rows. There we have the subcategories. Next, what we'll do is we'll create subcategory segments. Remember how we spoke about using calculated fields for segmenting our data back in the first video of this module? That's exactly what we'll do here. I'll create a subcategory segment, let's say for furniture. Now, here's what I want you to do. First, understand how we'll do this in this video, and then go ahead and pick out your own subcategory segments and calculate the average order value for them. Actually, what we'll do is we'll make an exercise out of that. Alright, back to the video. So I'm going to pick bookcases, chairs, furnishings, storage, and tables for my furniture segment. So let's go ahead and create a calculated field. You will already know by heart where this is located. So let's go ahead, click on create calculated field, and here we go. I am going to call it my furniture segment. Alright, let's type up the if else statement. So if drag and drop subcategory here is equal to bookcases. So you might be getting an idea of what I'm doing here. Or we'll drop subcategory here again is equal to chairs. So for each of the subcategories we picked out, we're gonna have to go ahead and do this. So, and we'll do this for furnishings. Remember this, what we're typing here has to match exactly with the subcategory here. So if I put F as small, it won't recognize furnishings. So just ensure that you do that whenever you're creating a calculated field using if else statements. Let's do that is equal to storage. And finally we're left with tables. So let's go ahead and do that. Then we want to name this furniture segment. So we go and do that. Otherwise, anything apart from these 5 should go into other segment. Just a crude example of how you can create 2 segments. You can of course experiment with it and end. Always remember to end an if else statement with this. Otherwise, again, Tableau will throw up an error. So once you're done typing this, just click OK. And there we have furniture segment under our dimensions. Let's see if that answers a business question. What is our average order value for the furniture segment? So I want you to do one thing. Drag furniture segment to rows. And there we have it. We can see the different segments in the second column here, where it's divided each subcategory into what it falls into. Now let me see how it tallies up with profit. So drag and drop an instance of your profit and put it here. And there you go. Sort this from top to bottom. Alright. Looking good. You can obviously create other segments at a more granular level and analyze each separately as well as together to help Superstore fine-tune their business model. Do you see how useful calculated fields make answering these business questions? It's honestly so helpful. If you want to remove subcategories and just look at the segments, you can do that as well. Just drag subcategory and drop it here. It'll remove it from the rows and there you go. We have the exact number for each segment, the profit. It's perfect, right? When you create different segments, of course, they'll show up in this column and you can analyze each one of them, compare them and so on. It's really helpful. We know how to leverage calculated fields for our projects. They're a nifty feature that lets us play around with existing data to make our analysis even more appealing and useful. In this video and the next few videos, we'll turn our focus to another really helpful feature, parameters. We've worked with mostly constant values so far. If you think about anything that we've seen, the data set we've seen, the different variables, it's been mostly constant. Even the newly engineered features that we use to showcase our analysis and help Superstore were constant values. Businesses do rely on that, but in my experience, the easier you make it for the end user, who's typically your client or stakeholder, the better your chances of succeeding. That's where allowing our users to pick and choose what they want to see in our visualizations comes in very handy. Take this for example. See these controls on the right of our Tableau workbook? These are super useful for dynamically controlling what you want to see on your screen and the end user screen. These controls are called parameters in Tableau. I honestly love Tableau's definition of parameters, so I'll just use it here. Parameters are dynamic values that can replace constant values in calculations, filters, and reference lines. They allow us to enhance the user experience and put the control in the end user's hands. Clients love this. There are 4 steps I learned when I was learning Tableau, and they're very helpful when you're new to parameters. I would strongly recommend using these 4 steps till you're comfortable with how parameters work, how to fine tune them, and so on. The first step is to create a new parameter, then show that parameter. Third is to create a calculated field using that parameter, and finally apply this calculation on your Tableau sheet. In the next couple of videos, where we'll be working hands on with parameters, you'll see how these 4 steps are implemented. And again, I'll emphasize it, just follow these very simple 4 steps whenever you're creating parameters initially. It'll really simplify the process for you. Here's another example of how a parameter looks and works in Tableau. This is what you'll be creating as the exercise by the end of the module. So take note of how we'll be creating parameters in the next couple of videos. And as you can see in this visualization itself, it's a very powerful visualization. The client can see the profit and sales, whatever he or she wants to see, just by using the drop down menu and selecting whatever the preference is. It's very, very useful. To understand what parameters are and how they work in a practical setting, we will head back to our Superstore project. Here we'll aim to answer the question of how do we select the top N customers of Superstore. We'll define what N means as we go along. This, as you can imagine, is a common business question. In order to create personalized recommendations, customizations, in order to reach out to customers, a business has to understand its customer base. And that's what we'll aim to do in this video. So go ahead and load your Superstore data in a new Tableau workbook. I'll just load that in here. We'll just give it a second. All right, drag and drop your order sheet here and head to sheet 1. And here we go. All right, let's begin. I want you to drag and drop customer name to your rows and sales to your column. Right. Now I want to have a control here that lets me select the top N customers. Just before I do that, go ahead and sort this from high to low. All right, perfect. So let's say I want to see my top 10 customers. A simple control somewhere here should help me do that. So question for you, can I use any variable that we have in the dimensions or measures sections? Take a moment to think about it. Can we do it? We'll have to create a new feature, right? We're going to create a calculated field that will create an index. This will help us with the parameter we will soon create, and you'll soon see why that is. So let's create the field and we'll call it index. So go ahead, click on create calculated field. We'll name this index. The formula to calculate the index is actually pretty straightforward. It's just index, open and close brackets. That's it. That's all we want. Click on OK. Now it shows up in the measures section. Do you think that's right? Not really. It's a dimension. It's not a measure. We aren't going to add or average an index, are we? It can't be a measure. This is actually a very good example to understand how Tableau is a tool and not a business model. We need to be very careful with these variables and ensure they don't fall under the wrong section. So why don't you go ahead and drag it into your dimensions? Just drag and drop it here. It's not working. Why do you think that is? That's because dimensions are discrete and measures are continuous. Keep that in mind. Dimensions are discrete and measures are continuous. It's a very helpful tip to keep in mind. Right now, the index is a continuous variable. Let's fix that. Drag index to your rows. Right, now click on this drop down arrow and select discrete here. And there we go. We have the index. That's actually exactly what we were looking for. Let's just make a small swap. I don't like that index is coming in front of the customer name. So just drag index ahead of customer, drop it, and that's exactly how index is supposed to work. Now it's time to create a first parameter. Top 5 customers. That's what you want to know. So drag and drop customer name, this time to your filters. Right, now go to top here, click on by field. Now we want to know the top 5 customers by sales numbers, right? So select sales in this instance and it automatically tells us that we need the sum of sales, which is exactly what we're looking for. So let's not change that. You can leave everything as is. Now click on this and click create a new parameter. Right. Now name your parameter and keep in mind this will be visible to your customers or stakeholders. So name it sensibly. Here we'll just call it top N customers. Right, leave everything as is. Just click all here and you're done. Okay, then click OK again and boom. We've just created our first parameter. Right now we have the top 10 customers by sales numbers. We wanted the top 5. So just go ahead and click 5 here, press enter, and there are your top 5 customers purely by sales numbers. That's how easy it is to create parameters, and that's how powerful they are. It's one of the most popular features I've seen among stakeholders. They love having control of the visualization, and parameters make it really easy for them to narrow down to exactly what they're looking for. Now, keep in mind that this is just one visualization. A real world Tableau project will have multiple such visualizations. So, parameters make it super easy to browse and get to exactly what we want. Let's take another example to understand the dynamic nature of parameters. These parameters, and you might have already intuitively understood this, parameters are heavily linked with calculated fields, and we'll see further evidence of that in this video. Just a note of caution, there'll be a lot of typing involved, so I would suggest following it on your machine as I type. So let's go ahead and create a new parameter. Just like calculated fields, there are different ways to create a parameter. We saw one way in the previous video. Another way is by going to this drop down menu next to dimensions and clicking on create parameter. So before I do that, let me open up a new sheet. We'll let this remain here. Right. Now let's create a new parameter. We'll name this one, let's call it measure values. What basically I'm looking to do is all the measure values that you see here, discount, profit, quantity, and sales, I'm going to give all of that to the client, to the stakeholder. Whoever is working with this particular visualization can look at these four numbers as and when they want to. That's what I want to do by creating this control, this parameter. So we'll call it measure values. Now change the data type to string. And this time we'll not select all, we'll select list. So go ahead and click on that. All right. Here we'll use the original measure values that came with Superstore's dataset. So go ahead and type each value that we'll be working with here. So we have discount and it'll display as discount automatically. The other one we're looking for is profit. Then we have quantity and finally we have sales, right? And the display as basically Tableau populates automatically, so we don't have to do anything there. Now I understand the temptation to click on add from field, but don't do that. Just this is very simple. It takes 10 seconds, so you can just type it out. Add from field actually creates other complications which we'll discuss later on in this course. So just leave it for now. Click on OK. Now, as you can see here, we have a new parameter called measure values, right? Right click on it and click on show parameter control. And here in the drop down, we can see the four measure values that we just input. But we aren't done yet. This is not yet useful to us. We need to first define where the different measure values will fit in. This is where calculated fields will come into the picture again. So let's go ahead and create a new calculated field, and you'll have mastered this by now. I am going to call this name of measure. You can of course name it as you see fit. Here we'll be mapping the four measure values to their respective variables. Remember in the parameter we've just defined the four values. Now we need to map it to their correct variables. So a bit of typing will be involved again. And for this we'll be using the case function. Anybody who's used Excel will be very familiar with how this works. So case, drag and drop measure values here. And we'll use a very simple when and then function. So when discount, basically the measure value that we input, then pick up the variable discount from the measure section. That's all you want. And we'll do this for each of the measure values that we input earlier. So when profit, then drag and drop profit here. Similarly, do it for quantity, then drag and drop quantity. And finally, we'll do it for sales, then sales. And remember to close it out with the end command. Now I want you to keep in mind that again, syntax matters every bit in Tableau. If I put this as small s, the calculation is still valid, but Tableau will not map sales to the correct variable. So ensure that this syntax is absolutely perfect before you hit OK, or it'll lead to all sorts of issues, right? Once you're done with this, just click on OK, and name of measure comes up into the measures section. All right. Now, drag and drop an instance of your order date onto your columns and drag name of measures onto your rows. Change the view to entire view. I don't like how it's just sitting in one corner. So I want the entire screen to be filled. So go ahead and do that. All right. And now you can play around with the parameter. Right now, we're seeing the discount year on year. So I can change that. I want to see the profit year on year. There you go. That's how you do it. Let's look at the sales year on year. Perfect. See how powerful parameters are. It's really helpful for the client. Now let's filter down to a more granular level and look at month on month sales, right? How do you think I can do that? Right now, we have the average of every month in the dataset. So what I'll do is just click here and click on month. Do you think this is what we're looking for? Not quite. We have the average of every month in the data set. So January has been averaged across the 4 years that Superstore has data for. It's not exactly what I'm looking for. So go back to your columns, click here, and this time select this month format. And there you go. That's exactly what we want. We have month on month data per year, and that's a lovely trend line. I would really encourage you to play around with the parameter again and see the level of detail we get for our superstore. You can do it by quarter, by week number, day, and so on. A lot of things to analyze. Have you ever worked on a project where you had data coming in from multiple places or sources? I'm sure you worked in Excel at least, where there were at least 2 or 3 or more sheets with data simultaneously. It's a common challenge in the industry, and this is something I want you to get familiar with. Our data isn't going to come from just one source usually. That's not going to happen. There'll be multiple tables and sometimes even multiple sheets and sources, which we will need to put together before we get to the analyzing step. Our data could come from any number of databases, for example, such as SQL, NoSQL, Cassandra, MS Access, and honestly, even Excel sheets or workbooks. So, in this module, we are going to learn about two very helpful and awesome techniques to help us deal with data coming from multiple sources. These are called data joining and data blending. These are two techniques, especially data blending, that you might not find very helpful when you're just starting out with Tableau. It's a little advanced, but I wanted to cover it in this course because you will eventually have to work with it when you get to the industry or when you take up an advanced project. So it's always good to have that knowledge. In this video and the next one, we'll focus on joining and its different types in Tableau. We'll then move on to cover the awesome concept of data blending. So, what do we mean by a join? Let's put a formal definition to it. Joining essentially is a method for combining the related data among common fields in different tables. The result of combining data using a join is a virtual table, as you'll soon see, that is extended horizontally by adding columns of data. Don't worry, we'll understand this using a very intuitive example in a moment. Before we do that, let's look at the different types of joins we can perform in Tableau. You'll be very familiar with this topic if you have any sort of background in SQL. The joins in Tableau work in pretty much the same manner. There are 4 types of joins we can do in Tableau. There's inner join, left join, right join, and something called a full outer join. These representative images that you can see for each join should give you an intuition about what each join can do. But let's look at each in a bit more detail now to understand how they work. So we'll be using 2 tables that you can see in this slide as an example to understand these different types of joins. Think of these as 2 tables or 2 sheets in the same Excel workbook. Both these tables contain information about employees, but both have different columns except name. So when we use an inner join to combine the 2 tables, it essentially returns the common values between those tables based on the common column. Think of it as an intersection between the 2 tables, as this highlighted portion shows. Now take a moment to look at these 2 tables. What column do you think we can do an inner join on? The common column, as I mentioned, is name, right? So an inner join will pass through that column on both tables and return the values that match. So in our example, the names Neha and Scott are common between the 2 tables. So what our inner join does is it matches those values and discards the remaining values which did not match. This is the final combined table we get from an inner join. Pretty straightforward, right? Let's use the same example to understand the left join. Here, the left table, this one, table 1, is used as the primary table. The left join finds the corresponding matches from the right table or table 2 in our example. This time, the values in the right table that do not have any corresponding match in the left table are discarded, and a blank or null cell replaces it. This is how the final combined table looks after performing a left join. A right join works in pretty much the same fashion, except this time the right table will be the primary table. The right join finds the corresponding matches from the left table, and the values in the left table that do not have any corresponding match in the right table are discarded. And we replace them, you guessed it, with null values. And this is how your final table looks like after doing a right join. I'm sure you're getting the intuition behind this, and if you ever get confused between these two, just look at this simple image and you'll get an idea of which table should be the primary one. I'm sure you've already figured out what a full outer join does. It returns all the values in both the tables. When a value from either table doesn't have a match with the other table, you see a null value in that data grid. Wondering what will happen in the final table? Well, here you go. This is the final table after doing a full outer join. As you can see, we have all the values that we initially had, except these are null values which have gone below the records that we had here. It's really that simple. So this video should have given you a solid base of how joins work and the different types of joins we can perform in Tableau. Let's see how to use all of them in Tableau in this video. We'll be using two examples to illustrate this. The first, which we saw in the last video, is an Excel workbook containing two sheets or two tables with employee data. So let's go ahead and import that into Tableau. The dataset is available just after this video, so if you want to follow along, you can just go ahead and download that on your machine. So I'll go ahead and load it into my Tableau workbook. Alright, so here we have two sheets or two tables, name 1 and name 2. Drag and drop the sheet named name 1 here, like we did with the orders sheet throughout this course earlier. We can see the data here populating, perfect. Now what I want you to do is drag the second sheet called name 2 and drop it next to name 1. This is something we haven't done before in the course, so let's go ahead and drop it there. Did you see what happened here? Tableau by default performed an inner join on the two tables based on the name column, which we can see by clicking on this icon. And you can see the name column was taken as the common column. So the resulting table only has values that correspond to both tables. The remaining values or rows have been discarded, like we saw in the previous video. And of course, you can intuitively remember the icon we saw for inner join, which was exactly this. If you wish to see or change the common column, simply click on this icon and Tableau displays the data source as I just showed. We don't have any other common column in our instance, but there will be times when you're working with data or tables that have multiple common columns. So you can go ahead and change it or add new ones as well. Let's do a left join next. It's actually pretty simple. Just click on the left icon and that's it. I'll go ahead and do that and close this. And you can see the resulting combined table after doing a left join here. I want you to take a second and figure out what went on here. Remember, in left join, the left table is the primary one. So all the values that were there are still there. The left join finds the corresponding values in the right table, keeps them and discards all the other values. That's why we have all these null values here. The same idea applies to the right join, except now the right table is the primary one. So let me go ahead and do a right join, click on that, close this, and as you can see, the values in the left table that correspond to the right one are still there, while the other values have been discarded and replaced by null values. And finally, the full outer join keeps all the values in this manner. So go ahead and click on that, close this, and there we have the final full outer join table. The values which did not correspond to the other table are shown in null for that grid. Perfect. It's pretty intuitive and straightforward to understand. This was a simple example to give you an intuition behind joins and how they work in Tableau. Now let's close this and open up a new instance of Tableau. We'll now be working with the Superstore data again. So let's go ahead and click on a new worksheet. I want you to do that as well. So go ahead and import the Superstore data. We'll now be working on the Superstore data again. So go ahead and import the Superstore data into your Tableau workbook. So I'll just do that here. And we'll just load it in. Perfect. You know the drill by now. I want you to pause this video and figure out which two tables should be joined. Got it? We'll be joining the orders and the return sheet. The return sheet contains two columns, which I will just show to you here. We have the order ID and we have which items, which orders basically were returned. And the orders sheet, which we are very familiar with at this point in the course, contains a multitude of columns. And the common column between the two is, of course, the order ID. And that's what we will use to see how the different join operations will work on a Superstore dataset. So go ahead and drop your orders sheet or table here as we've done previously. Then drag and drop your returns sheet next to the orders sheet. As we saw before, Tableau has performed by default the inner join operation. So we only have those rows in this resulting table that were common, aka the orders that have been returned. And as you can see here, the returns table has been added here, the returned column and the order ID column. Perfect. Let's do a left join next. Click on this, simply select left, and there you go. And just keep in mind that the data source is the order ID here, which is the common column. Alright, so what do you think happened in a left join here? We should see, yes, the entire order tables on the left. The returns table, however, which will be the last two columns on the right, will have a ton of null values, as you can see here. Why? Because remember, left join discards the values on the right table that did not correspond to the left table. Since not all the orders were returned, that's why there are a bunch of null values here. Alright. Now here's the interesting part when we do a right join. You would expect to see a ton of null values in the left table, right? Well, let's see what we get. Click on this icon, click on the right join, close this. Interestingly, there are no null values here. Why is that happening? Well, this is because all the values in the right table were already available in the left table. Remember, these are the orders that have been returned. So of course they would be available in the full-blown orders dataset. That's why there are no null values reflecting it. This is where your business sense has to come in. And finally, the full outer join works pretty much as you would expect. Click on that, close this. All the values are in the table, and the right table has a bunch of nulls again. Because again, not all orders were returned. It's pretty easy to understand. Now again, I'll reiterate this because I feel this is a very important concept that you'll carry through when you break into the industry or when you're working on a different project on your own or for somebody else. Because this Superstore problem is a real world problem. And there's a very good chance you might work on data or multiple sheets of these kinds. So I would suggest first trying this on your own machine, understanding what each join did, and then getting back to this video again and just going through it. You can pick up a dataset, any dataset you want that has multiple tables, just perform all these 4 join operations and see what kind of resulting table comes out of it. Because here, the orders return table, of course, did not have any unique value that were not present in the orders table. That might not always be the case. So go ahead, pick up any data set that has multiple tables with different data, with different columns, and see how that works. Joining is indeed a very useful technique to combine the data present in different tables. We covered how to do that in Tableau in the previous video. Now, I want to introduce you to a slightly different technique, but a very powerful one that you'll often find yourself using in the industry. I mentioned in the first video of this module, and I'll reiterate it here. Data can come from multiple sources when we're working on real-world projects. This is especially true when you're working with multiple teams or need to pull in a ton of data before you get to the analyzing and exploring aspect of your project. I've worked on projects where we had to pull in data from all sorts of data sources, including SQL and NoSQL databases, Excel, Google BigQuery, Oracle database, and honestly even MS Access, among others. You'd be required to get all these sources into one view or Tableau workbook. How can we do this? Welcome to the world of data blending. This is a slightly advanced topic, but I want to cover it here because there's a very high chance you'll be asked about it in any interview you sit for where Tableau is concerned. Even if you don't use it, you should at least be aware of what data blending is and how it works, at least at a high level. So, to put a formal definition to data blending, it's a method that allows us to combine data from multiple sources. And this is what I like. We can bring in additional information from a secondary data source, and data blending displays it with data from the primary data source directly in the same Tableau view. Now, you might be wondering at this point, why not just use joins that we learned in the previous lessons? Why introduce a new and seemingly complex topic? To answer that, we have to understand the difference between data joining and data blending in the context of Tableau. Data joining, which we've covered so far, helps join the data that comes from the same source. Jog your mind back to the examples we saw. All the data we used, albeit in different tables, came from that same Excel sheet, right? In data blending, on the other hand, the data comes from multiple and different sources. We'll see that soon in the next video. Data joining basically combines the two tables or sheets together into one table. That's exactly what we saw. Data blending keeps the two data sources separate, which I honestly find quite neat. The join happens at row level in data joining, whereas the results are aggregated at an appropriate level when we use data blending. Remember how we use the orders and return sheet to perform data joining? Well, data blending typically uses different sources, even if it's two different Excel workbooks, or let's say an MX Access database and an Excel workbook. Let's take a simple example to understand data blending. Here are two tables I've taken from two different data sources. Table 1, which is under data source 1 here, has a ton of details about orders like order ID, order date, ship date, state, subcategory, sales numbers, and a whole host of other variables which are not displayed here. Table 2 only has three variables: month, state, and target. Our aim is to compare the sales and target numbers at a product level, and that's where data blending helps us. Data blending, just like joins, requires a common column to connect the different sources. Can you find that between these two sources? Well, as far as you can see, it's the state column, right? Now, here's the problem we're facing. These two tables have a vastly different level of granularity. Data source 1 has data about subcategories, about items, while table 2's granularity extends only to the state column. That's a problem. Because if we try to roll this table up here, we'll lose a ton of information. We'll have to roll it up by the date and state columns in order to match table 2's level of granularity, right? That's fine if our aim is to compare the target and actual sales per month or per state. But remember, our aim is to create a dashboard for our leadership team, and if we lose all these granular details, which is what will happen when we roll this table up, well, then that's a recipe for disaster. That's not what we want. We don't want to lose any information that we have. And that's where data blending is helpful. The superstore has another vertical in the form of coffee chains spread across the United States. While superstore is the primary revenue generator, the coffee chains have been in existence for a while as well, so they have a bit of data collected for them. Now, the superstore leadership team wants us to figure out the total sales from both superstore as well as the coffee chain. And they want us to present that to them in the form of a wonderful visualization. You can download the coffee chain dataset from the link I've provided after this video. So just go ahead and download that so you can follow along as we do this. Alright, first load your superstore dataset into Tableau. Let's go ahead and do that. Now drag and drop the orders sheet here as you've done countless times before. Head to sheet 1. Now this is where it gets fun. Go to data on top of your Tableau workbook. Click on that and click on new data source that you'll see. Now here, navigate to wherever you saved the coffee chain dataset and import that into Tableau. So I'll just go ahead and do that. Click on it and just click open. This, as you can see, is in a .tde format, which stands for Tableau Data Extract. Right, here we have the coffee chain dataset. This contains data about the different orders at each coffee chain across the United States that Superstore owns. So we have columns like COGS, state, inventory, margin, market, product ID, product type, and so on. And of course the profit and sales numbers along with the state and total expenses. So it's pretty granular information. Head back to sheet 1 again. Instantly, you'll see on the top left that we have two data sources that we've just imported. Now, click on the Superstore data source. Alright, grab the state dimension and put that into rows. Just To reiterate, this is from the Superstore dataset. So just ensure that's the state variable you're picking up. Put sales into columns. Alright. Don't sort this from high to low yet. Next, I want you to click on the coffee chain dataset here. Put the sales from here right next to the sales from the order sheet. Go ahead and do that. What can you infer from this? What do you think is happening here? At the top left, our Superstore dataset has a very small, almost indiscernible blue tick. That means this is a primary source. The coffee chain dataset has a small orange tick next to it. That means that's a secondary source. Our state variable also has an orange chain next to it. This means this is the blended field, the common column between the two sources. Tableau has picked that up by itself. Now there's an issue with this visualization. There's something I don't quite like. I can see a lot of null values here in the coffee chain sales chart. More than 29 nulls in fact. This is because the coffee chain stores are not present in every state in the US. Only a few selected ones. On the other hand, the Superstore is in 50 states. So we need to deal with these null values. This doesn't really look nice. To do that, go ahead and drop all the variables that we had picked up. Just go ahead and drop them. No mercy here. Just remove them from your Tableau worksheet. Now, this time we will take the states variable from coffee chain. So go ahead and drop that into your rows. Put sales into your columns here. Head to the Superstore source, grab sales and put that next to your coffee chain sales. And we have a similar chart, but this time we've removed all the null values. We only have the states from the coffee chain source. Perfect, that's exactly what we wanted here. Now I'm going to introduce a new chart type called an area chart. It's actually quite useful to graphically represent quantitative data. So how do we change this to an area chart? Just go here under marks, click on the drop down and simply select area from here. That's it. Nice. Our next job is to merge the two charts into one. Because you want to give the Superstore leadership team one singular view to compare the two sales, not two different charts. That makes not a lot of sense, honestly. So how do we merge the two charts? We've covered this concept before. Just can you recall what we need to do? Yes, dual axis charts. So right click on the axis of this chart and select dual axis. That looks beautiful. The lines here represent the sum of sales for both the Superstore as well as the coffee chain outlets. You can play around with the colors. Just go here, click on edit colors and select the palette that you want. So I'm just going to go ahead and select brown for my case. Okay, and it changes its color. Just go ahead and play around with that. So this is a taste of how blending data works in Tableau. I would encourage you to play around again with the colors, play around with different variables, see what you can come up with.